Hi friends, my name is Maruti and I'm the co-founder of Kraku. In this video, we'll be looking at 70 plus questions from the geometry topic for CAT. Many students find geometry to be very difficult. They have some sort of paranoia with respect to geometry. So if you look at this question and if you look at the way in which I have solved it, I try to explain all the concepts in each of the questions. So I'm sure you will understand both the concepts, the important formulas, as well as know how to solve the questions. So definitely I think this video which will be very useful for you. If you found this video to be useful, I would recommend you to check out two playlists that we have. One playlist is the CAT revision playlist, where we are having two videos where the entire concepts, all the important formulae for CAT are explained. There is one video where you can revise the entire portion for verbal within 1.5 hours. And there is one video where you get the basics of all the important types of LRDs that are asked. This is the CAT revision playlist and it is watched by lakhs of people. The second most important playlist is the set of topic-wise questions that we have made, similar to the one that we have made in this particular video. You will find topic-wise questions in arithmetic, algebra, geometry, modern maths and number systems. Again, lakhs of students have watched this question videos. So definitely check out the playlist of the topic-wise questions as well. The links for both of them are given in the description of this video. If you find this video to be useful, please do like it. And if you are having trouble with any of the questions that I have solved in the video, please do comment below this video. I look at all the comments and I'll try to respond to them to the best of my ability. In this question, we are given a circle which is x square plus y square plus 4x minus 6y minus 3 is equal to 0. So this, you can complete a perfect square. This is x square plus 4x plus y square minus 6y is equal to 3. You add a 4 here and a 4 here. You add a 9 here and a 9 here. So this is x plus 2 whole square plus y minus 3 whole square is equal to 16. So this is basically a circle. The center of the circle is minus 2, 3 and the radius of the circle is square root of 16 which is equal to 4. Now suppose there is a point over here such that if you are drawing two tangents from this point to the circle, the angle between the tangents is 60 degrees. How can we calculate the locus of that point? What exactly is locus? Locus basically means what is the equation that this point has to satisfy. Let us assume that this is a point A and let the coordinates of x and y, let the coordinates of A be x and y. So what is the property that x and y satisfy? If you know the property that x and y satisfies, that is called the locus. Now to be honest, right now we don't know whether this will be a circle, whether this will be another curve, this will be a straight line, we don't know. Or whether this will be a single point, that also we don't know. We just know that what locus means is what is the equation that this point x comma y has to satisfy. Now we know that the information we know is that this is 60 degrees. And if you join the center to the point of intersection of the tangent and the circle, this will be 90 degrees. The radius of the circle we know is 4 units. So this is 4. If the center is O, if you join A to O, because the tangents are intersecting at 60 degrees, this angle over here will be half of it, which is 30 degrees. Therefore, the length of AO will be 8 units. Why is that the case? Because if you are assuming that this is a right angle triangle ABO, one side is 4 units, one angle is 30 degrees, the other one is a right angle. This would imply that BO divided by AO is equal to sine 30 degrees, which is equal to 1 by 2. Using this, we can calculate that AO is equal to 8 units. Now we can get an equation that x comma y has to satisfy, because this point x comma y has to be at a distance of 8 units from this point O, which is minus 2, 3. So x plus 2 whole square plus y minus 3 whole square has to be equal to 8 square, which is 64. This is the equation that x and y has to satisfy, or to put it in another way, this is the locus of the point A. Now what are we required to calculate? What is the point at which this locus touches the line x is equal to 6? Basically, we are saying what is the point of intersection of this curve, which is basically a circle, and the line x is equal to 6. When x is equal to 6, 6 plus 2 whole square is 8 square. So 8 square plus y minus 3 whole square is equal to 64. Or y minus 3 whole square will be 0 or y will be equal to 3. So the point of intersection is 6, 3, which is option B. In this question, we are told that there is a quadrilateral ABCD which is inscribed in a circle. So it is a circular quadrilateral. It will look something like this. This is a circle. let us assume that this is the quadrilateral. This is AB, and this is CD, this is BC, and this is A, B, C, and D, and BD and AC intersect at E. So this is BD, and this is AD. This is E. AB is to CD is given, that is 2:1. So let us assume that this is 2x and this is x. Similarly, BC is to AD is given, this is 5:4. So let this be 5y, let this be 4y. Now we can see a couple of similar triangles. One similar triangle is AED is similar to BEC. Another similar triangle is ABE is similar to DEC. I'll explain why these two are similar, then you can infer the same for the second pair also. If you're looking at AED and BEC, this angle is the same as this angle because both of them are the angle subtended by the chord AB at the circumference, so both of them are the same. Similarly, both these also will be the same because this is the angle subtended by the chord CD at the circumference, and the third angle will obviously be the same. This also is the same. So if you assume that the length of AE is P, what can we infer about the length of B? We are looking at AED and BEC. So AE divided by BE is equal to 4y divided by 5y, which is equal to 4 by 5, or the length of BE will be equal to 1.25 p. So this is equal to 1.25 p. Similarly, if you assume that the length of ED is q, the length of CE is 1.25 q. What are we required to calculate? We are required to calculate the ratio of AE is to CE. That is, we are required to calculate the ratio of P divided by 1.25 q. So we need to calculate the ratio of P and Q. For that, we will use the other set of similar triangles, which is ABE and CED. Because both of them are similar, the ratio of AB divided by CD will be the same as the ratio of P, which is AE. AE is opposite this angle, and in this will be this, which will be AE divided by DE. This is equal to 2:1. What is AB by CD? That is 2:1. So AE divided by DE has to be 2:1. AE is equal to P, DE is equal to Q. So P by Q is equal to 2:1, or P is equal to 2Q. Once you know that P is equal to 2Q, you can figure out the ratio of AE is to CE. AE will be P, which is 2Q. CE is 1.25Q. So the required ratio is 2:1.25, which is equal to 8 by 5. So the answer for this question is option C. Just to reiterate, if you draw a quadrilateral like this, this is ABCD, which is a cyclical quadrilateral. This is A, B, C, and D. We have the diagonals which intersect at a point E. This is E. First, because you know that this is 2x, this is x, this is 5y, this is 4y. First, using one set of similar triangles, you will calculate that if this is P, this will be 1.25 P, because AED is similar to BEC, and if this is Q, this will be 1.25 Q, because that ratio of the sides of these two triangles is 5:4. Using another set of similar triangles, you will calculate that P by Q will be equal to 2:1. Here we are using the similar triangles AEB is similar to CED. So P by Q is 2:1. So the required ratio is P divided by 1.25 Q. P is 2Q. So this is 8:5. So the answer for this question is option C. In this question, we are told that in a right angle triangle ABC, the altitude AB is 5 centimeters, the base BC is 12 centimeters. So let us assume that this is how the right angle triangle is. This is A, B and C. This is A, B and C. AB is 5 centimeters, BC is 12 centimeters. P and Q are points on BC such that the areas of ABP, so let us assume that this is on BC, right? So wait, this is ABP, ABQ and ABC are in an arithmetic progression. So this is P, this is Q. If the area of triangle ABC is 1.5 times that area of triangle ABP, find the length of PQ in centimeters. What is the area of triangle ABC? The area of triangle ABC is half into 5 into 12, which is equal to 30 centimeters square. So the area of triangle ABP will be 30 divided by 1.5, which is 20 centimeters square. So the area of ABP is 20 centimeters square. So what is the length of BP? If you assume that this is x, half into 5 into x is equal to 20, or the value of x is 8 centimeters. So this will be 8 centimeters. This overall is 12 centimeters. What is the area of ABQ? Because we know that ABP is 20 centimeters square, ABC is 30 centimeters square, and if ABP, ABQ and ABC are in arithmetic progression, the area of ABQ will have to be 25 centimeters square. So half into BQ into AB, which is 5 centimeters, is equal to 25, or the value of BQ will be equal to 10 centimeters. So this over here is 10 centimeters. This is 8 centimeters. So the length of PQ will be equal to 2 centimeters. So the answer for this question is 2. In this question, we are told that let triangle ABC be an isosceles triangle such that AB and AC are of equal length. AD is the altitude from A to BC and B is the altitude from B to AC. If AD and BE intersect at O such that angle AOB is 105 degrees, then what is the value of AD divided by BE? So let us first draw an isosceles triangle. Let us assume that this is the isosceles triangle ABC. This is A, this is B and this is C. Let the altitude from A to BC, this AD be this, and let the altitude from B to AC be this. This is AD, this is BE. Let the length of AB be small a, therefore the length of AC is also small a. This is 90 degrees, this is 90 degrees because they are altitudes. We are told that this is O and angle AOB is given to be 105 degrees. If angle AOB is 105 degrees, angle AOE will be 75 degrees. So this is 75 degrees. This would tell us that angle OAE, this will be 15 degrees. Why is this 15 degrees? Because these are three angles of a triangle. This is 90 degrees because this is the altitude. Another angle is 75 degrees. So the third angle will be 15 degrees as the sum of the three angles of a triangle is 180 degrees. This would imply that angle BAD is also 15 degrees. Why is that the case? Because in an isosceles triangle, if you have an isosceles triangle like this, if you are drawing a altitude from the vertex, that is if these two sides are the same, in an isosceles triangle, if you are drawing an altitude, it will also be the median. These two will be the same and these two angles also will be the same. That is true only if you are drawing a altitude from the vertex of the isosceles triangle, that is these two sides should be the same. So in this particular case, this angle will also be 15 degrees, this also is 15 degrees. Now can you calculate the length of AD? If you are looking at triangle ABD, in triangle ABD the hypotenuse is A, the adjacent side is 15 degrees. So AD divided by the hypotenuse, which is AB, is equal to cos of 15 degrees, or AD is equal to AB, which is small a, into cos 15 degrees. Now if you are looking at triangle ABE, this also is a right angle triangle. Here also the hypotenuse is A, which is AB. Now, if you're looking at the angle opposite this entire angle, which is 30 degrees, sine 30 degrees is equal to BE divided by AB, or the value of BE is equal to small a divided by 2. This is the value of BE, this is the value of AD. Therefore, the ratio of AD divided by BE is equal to 2 times cos 15 degrees. So, the answer for this question is option C. In this question, we are told that there is a semicircle of radius 2 centimeters. We are required to calculate the ratio of the length of the largest lengths of the, basically the ratio of the length and breadth of the rectangle. So, let us first draw a circle, then let us draw the diameter. We are looking only at the semicircle. Let us assume that this is the semicircle we are looking at. The top part of semicircle. In this semicircle, a rectangle is drawn. So, the rectangle will be something like this. This is the largest rectangle that is possible in this semicircle. Now, let this be the center of the semicircle. Let us connect the one vertex of the semicircle to the center of the circle. Center of the semicircle. Let this be O. Let this semicircle be A, B, C and D. Let the length of BC be equal to A. Let the length of OC be equal to B. OB is the radius of the circle. This is R. This is 90 degrees. And we know from Pythagoras theorem that A square plus B square is equal to R square. What are we required to maximize? We are required to maximize the value of A into 2B. Because this is B, O is the center of CD. The area of the rectangle is length into breadth. This is A into 2B. So, we are required to maximize 2AB. And what is the condition we have? We know that A square plus B square is R square. So, A square plus B square is equal to R square. That and we are required to maximize 2AB. This would happen only if A is equal to B. How do you know this? We can use the arithmetic mean is greater than or equal to geometric mean, which essentially says that A square plus B square is always greater than or equal to 2AB, and this equality will occur only when A is equal to B. That is 2AB, which is the area of the rectangle, is always less than or equal to R square, and it will equal R square when A is equal to B. So, the area of the rectangle is maximized when A is equal to B. In that particular case, A is equal to B is equal to R divided by root 2. Anyway, this will be A, this will be A, and this will be A. So, the breadth of the rectangle is A, the length of the rectangle is 2A, because this is A and this is A. So, the ratio of the largest side to that of the smallest side is 2:1. So, the answer for this question is option A. In this question, we are told that in a regular polygon, the interior angle exceeds the exterior angle by 120 degrees. What is the number of diagonals in this polygon? We know that if there is a n-sided polygon, n-sided regular polygon, the exterior angle, each of the exterior angle will be equal to 360 divided by n. And the sum of all the exterior angles in an n-sided polygon is always equal to 360 degrees. So, each one of them will be 360 by n. And each interior angle will be equal to n minus 2 into 180 divided by n. Because we know that in an n-sided polygon, the sum of the interior angles will be n minus 2 into 180. Now, what we are told is that n minus 2 into 180 divided by n is equal to 360 by n plus 120. This, if you simplify, is equal to 180 minus 360 by n. This we are told is equal to 360 by n plus 120, or the value of 60 is equal to 720 by n, or the value of n is equal to 12. So, the number of sides in that regular polygon is 12, and we know that in an n-sided polygon, what is the number of diagonals? The diagonals will be n into n minus 3 divided by 2. In an n-sided polygon, the number of diagonals is n into n minus 3 divided by 2. Here the value of n is 12. So the number of diagonals is 12 into 9 divided by 2, which is equal to 54. So the answer for this question is 54. In this question, we are told that there is a triangle which is drawn such that the vertices of the triangle are on a circle C. So let us assume that this is how the circle is and this is how the triangle is. One of the sides of the triangle is the diameter. Let us assume that this is A, this is B, and this is C. Now, if this is the diameter, we know that angle C has to be 90 degrees. Why is that the case? Because the angle subtended by a diameter on the circumference of a circle is always 90 degrees. So, once this is 90 degrees, we are told that the remaining two sides are in the ratio of A is to B. So, let this be equal to A into K for some constant K. This will be B into K. Therefore, the length of the hypotenuse AB will be K into square root of A square plus B square. But we are told that the radius of the circle is R. So 2 times R, which is the diameter, is equal to K into square root of A square plus B square. So now we can actually calculate the value of K. K is equal to 2R divided by square root of A square plus B square. What is the area of this triangle? The area of the triangle is half into side AC, which is equal to AK, into side BC, which is equal to BK. So the area of the triangle is AB by 2 into K square, which is equal to AB by 2 into 4R square divided by A square plus B square. This is equal to 2AB R square divided by A square plus B square, which is option B. In this question, we are told that there is a rectangle ABCD where AB is 9 centimeters, BC is 6 centimeters. So let us assume that this is how the rectangle is. This is A, B, C, and D. AB is 9 centimeters, BC is 6 centimeters. There are 2 points on BC such that the areas of the figures ABP, APQ, and AQCD are in a geometric progression. So let us assume that this is ABP, this is APQ, and the remaining one is AQCD. This is P, this is Q. We are told that the area of the figure AQCD is 4 times the area of triangle ABP. So if you assume that the area of triangle ABP is A, the area of the quadrilateral AQCD is 4A, and because the 3 figures are in geometric progression, this has to be 2A. That is, the area of APQ has to be 2A, because APQ, ABP, APQ, and AQCD are in a geometric progression. If this is A and if this is 4A, the middle term has to be 2A. Once you get this idea, we are asked to calculate the ratio of BP is to PQ is to QC. What we do know is that the total area of the rectangle is 9 into 6, which is 54. So 4A plus 2A plus A, which is 7A, is equal to 54, or the value of A is equal to 54 by 7. So we can calculate the length of BP. Half into BP into 9 is equal to 54 by 7. This is 6, or the value of BP is equal to 12 by 7. So this is 12 by 7. Similarly, the length of PQ will be twice that, which is equal to 24 by 7. We know that the overall length of BC is 6 units. The length of PQ plus PB is 24 by 7 plus 12 by 7, which is equal to 36 by 7. So this will be 6 by 7. This would tell us that the required ratio of BP is to PQ is to QC will be 12 is to 24 is to 6, which is equal to 2 is to 4 is to 1. So the answer for this question is option C. In this question, we are told that there is a trapezium ABCD such that AD is parallel to BC. So this is ABCD. And this is how the trapezium is. This is A, this is B, this is C, and this is D. AD is parallel to BC, and we are told that angle BAD is 90 degrees. So this is 90 degrees. We are told that BC is 3 centimeters. So this is 3 centimeters. And AD is 8 centimeters. This is 8 centimeters. Now we are given the perimeter of this trapezium, that is 36 centimeters, of which we know the lengths of two sides. One is 3 and the other is 8. So the sum of the lengths of the remaining two will be 36 minus 11, which is equal to 25 centimeters. So the sum of this plus sum of this is 25 centimeters. Now because this is 90 degrees, let us draw a perpendicular from C which will intersect AD at a point, say E. This is a perpendicular that is drawn like that. Now because this is a trapezium, BC is parallel to AD, this also will be 90 degrees, and therefore this is a rectangle such that AE will be 3 centimeters, which is the same as the length of BC, and ED will be 5 centimeters. If you assume that the length of AB is x, CE will also be equal to x, and the length of CD will be square root of x square plus 5 square, which is 25. So the value of x plus square root of x square plus 25 is equal to 25. Now square root of x square plus 25 is equal to 25 minus x. If you square on both sides, you are going to get x square plus 25 is equal to 625 minus 50x plus x square. You cancel x square on both sides. We are going to get 50x is equal to 600, or the value of x is equal to 12 centimeters. So this will be 12 centimeters. Now if you are trying to calculate the area of this trapezium, the area of the rectangle BCAE will be 12 into 3, which is equal to 36 centimeters, and the area of the triangle CED will be half into base, which is 5 centimeters, into height, which is x, which is equal to 12 centimeters. This is equal to 30 centimeters square. That will be the respective areas. So the sum of the areas of these two, which is the area of the trapezium, will be 36 plus 30, which is 66 centimeters square. In this question, we are told that there is a circle, and inside this circle we have a rectangle. The radius of the circle is given to us, that is r. So let us assume that this is how the rectangle will be. Let the length of the rectangle be L, let the breadth of the rectangle be B. This also will be B, this also will be L. Now if you connect one of the diagonals, this diagonal will be a diameter of the circle. So the length of this diagonal will be 2r, and this is 90 degrees. So using Pythagoras theorem, L square plus B square is equal to 4r square. And we are also given the perimeter of this rectangle. The perimeter will be L plus B plus L plus B. So L plus B will be equal to perimeter divided by 2. Using these two equations, we are required to calculate the area of the rectangle. That is, we are required to calculate the value of the product of length and breadth, that is L into B. You can just square the second equation. So you are going to get L square plus B square plus 2LB. This is equal to P square by 4. From this, if you subtract the first equation, you are going to get the 2LB is equal to P square by 4 minus 4r square, or the value of L into B is equal to P square by 8 minus 2r square. So the answer for this question is P square by 8 minus 2r square, which is option B. In this question, we are told that there is a parallelogram. Let us assume that this is the parallelogram. We are given 3 vertices of the parallelogram. We are required to calculate the 4th vertex. This is a fairly straightforward question. Let us assume that this is A, this is B, this is C, and this is D. The coordinates of A are 1, 1. The coordinates of B is 3, 4. Coordinates of C is minus 2, 8. And coordinates of D we don't know. Let us assume that they are x, y. What do we know about a parallelogram? If you draw the diagonals of the parallelogram, they intersect each other and they bisect each other. That is, the midpoint of DB and the midpoint of AC are the same. The midpoint of AC can be easily calculated. The midpoint of AC will be 1 plus minus 2, that is minus 1 divided by 2. And the y coordinate will be 1 plus 8, that is 9 divided by 2. This will be the same midpoint between D and B. That is 3 plus x divided by 2 is equal to minus 1 by 2, and 4 plus y divided by 2 is equal to 9 by 2, or the value of x will be equal to -4 and the value of y is equal to 5. So the coordinates of D are -4, 5, which is option D.
Google search Krakow CAT formulas PDF. Click on the first link. You will get a list of topics for CAT. Click on one of the topics. Download the PDF to get a list of formulas for the topic.
In this question, we are told that there is a triangle ABC such that altitudes AD and BA are drawn to the corresponding bases. So let us assume that this is the triangle ABC. This is A, this is B, this is C. We have AD, which is drawn like this. This is one altitude, and we have BE, which is drawn like this. This is another altitude. This is AD, this is 90 degrees, and this is BE. This also is 90 degrees. What we are told is that angle BAC is 45 degrees. So this angle BAC over here is 45 degrees. As angle AEB is 45 degrees, this would imply that over here angle ABE is also equal to 45 degrees. Because if you are looking at triangle ABE, one of the angle is 90 degrees, that is known, that is an altitude. Another angle is 45 degrees, this is given to us. The sum of the three angles has to be equal to 180 degrees. So the third angle will be 180 minus 90 minus 45, which is equal to 45 degrees. So immediately we will figure out that triangle ABE is isosceles. It is a right angled isosceles triangle because two angles are the same, they are equal to 45 degrees. This would imply that BA is equal to AE. And if you are assuming that both of them are equal to x, if this is x and if this is x, we can calculate the length of AB. AB will be equal to x root 2. Now, we are also told that angle ABC, this big angle over here, is theta. So what is the value of sine theta? Sine theta is equal to opposite side, which is AD, divided by the hypotenuse, which is x root 2, which is AB. This is equal to AD divided by x root 2, or AD divided by x is equal to root 2 into sine theta. But what is x? X is basically equal to AE, which is equal to BE. So the ratio of AD divided by BE will be equal to root 2 sine theta. So the correct answer is option D. In this question, we are told that there are regular polygons A and B, and the ratio of the number of sides of them is 1:2, and the ratio of their interior angles is 3:4. We are asked to calculate the number of sides B has. So let us assume that the number of sides of A is n and the number of sides in B is 2n. We know the sum of the interior angles of a n-sided polygon. This will be equal to n minus 2 into 180. So the sum of the interior angles of polygon B will be 2n minus 2 into 180. So each interior angle of A will be n minus 2 into 180 divided by n, and each interior angle of B will be 2n minus 2 into 180 divided by 2n. You can cancel n in the denominator. This will be 90. 180 divided by 90 is 2. So the required ratio is n minus 2 divided by, you can cancel 2 in the numerator, and 2n minus 2 divided by 2 is n minus 1. So the required ratio is n minus 2 divided by n minus 1. This is equal to 3 by 4. You can cross multiply. So 4n minus 8 is equal to 3n minus 3, or the value of n is equal to 5. So the number of sides of polygon B will be equal to 2n, which is 2 into 5, that is 10. In this question, we are told that the length of each side of an equilateral triangle is 3 centimeters, and let D be a point on BC such that the area of triangle ADC is half the area of triangle ABD. We are required to calculate the length of AD. So let us first draw the triangle so that we have a sense of what is being given and what is being asked. So this is an equilateral triangle. This is ABC. Now we have a point D such that area of ADC is half that of ABD. So D is something like this. So using this information, we can calculate the length of BD. How can we do that? This is 3 centimeters, this is 3 centimeters, and the length of BC is 3 centimeters. Now if the area of ABD to the area of ADC, this ratio is equal to the length of BD by the length of DC. Because the height of both the triangles will be the same. The height of both the triangles will essentially be the length of the perpendicular from A to BC. Whatever is this length, if this is E, that will be the height. A will be the height of both the triangles, and therefore the ratio of the area is basically the ratio of their bases. If the ratio is basically equal to 2:1, ABD is twice the area of ADC. So DC will be 1 and BD will be 2 centimeters. We also know that this angle is 60 degrees because ABC is an equilateral triangle. So using the cosine rule, we can calculate the length of AD. What is the cosine rule? If you have a triangle, the lengths of the sides are A, B and C. And if the angle opposite the side C is C, capital C, then A square plus B square minus 2AB cos C is equal to B square. A square plus B square minus 2AB cos C is equal to B square. In this particular case, we know that one of the sides A is 3 centimeters, one of the side B is 2 centimeters, and the angle between them is 60 degrees. So that will mean that 9, which is 3 square, plus 4, which is 2 square, minus 2 times 3 into 2 into what is cos 60? Cos 60 is equal to half, will be the length of AD square. You can cancel both of this. This is 13 minus 6 is equal to AD square, or the length of AD is equal to square root of 7. So the correct answer is option C. In this question, we are told that there is a triangle ABC. Let us assume this is ABC, this is A, this is B and this is C. The medians BD, so B will be over here, this is BD, and CE, this will be CE, this is BD, this is CE, they intersect at point O. The area of the triangle ABC is given to be 108 square centimeters. We are required to calculate the area of triangle EOD. So let us join E and D. Let us assume that the area of EOD, triangle EOD, is equal to P. What can we say about the area of triangle EOB? This area will be 2P. Why is that the case? The reason for that is because O is the centroid of the triangle ABC, and every centroid divides the median in the ratio of 2:1. So this will be 2 and this will be 1. The length of OB to that of OD is 2:1. Similarly, the length of OC to O will also be 2:1. So this will be 2 and this will be 1. That is the ratio. Just for the sake of understanding, this can be 2A and this will be A, and this will be 2B and this will be B. Now this would imply that the area of triangle COD will be 2P. And what is the area of triangle BOC? This will be 2 times 2P. This will be equal to 4P. If you are trying to understand why this is the case, imagine that you have a triangle like this. This is a separate triangle. Now suppose a line is drawn to some point on the base. Let this be X, Y and Z, and let this be W. The ratio of triangle, the area of triangle XYW to that of the area of WXZ, this area is equal to, this ratio is YW divided by ZW. Because the height of triangle WXY and the height of triangle WXZ, both of them are the same. The height will essentially equal the length of the perpendicular drawn from X to YZ. So if the height is the same, the ratio of the areas is basically the ratio of the length of the bases. So in this case, this will be equal to XW by XZ. Whatever is this ratio, that will be the ratio of the areas. If you are using this concept multiple times, you will be able to easily figure out the respective ratios of the areas of the triangles. If you are looking at EOD divided by BOE, this ratio is same as this is O, so this is same as OD divided by OB, and because centroid divides this in the ratio of 2:1, this will be 1:2. So if this is P, this will be 2P. For the same exact reason, area of triangle DOC will be 2P. Now if you are comparing the areas of triangle EBO, that is this triangle, and triangle BOC, this is equal to EO, that is this length, divided by CO, that is this length. This also will be 1/2. We know that the area of triangle EBO is 2P, so this will be equal to 4P. That is how we got it. Now we know that ED is dividing the sides AB and AC in the ratio equally, because this is basically the medians. So now we know that if the area of triangle AED is say Y, the area of the bottom part is P plus 2P plus 4P plus 2P, this is equal to 9P. Now we know that area of triangle AED divided by area of triangle ABC is equal to 1:4. We'll come to that. Right now just accept that it will be 1:4. So this would imply that Y divided by Y plus 9P is equal to 1:4. Or if you simplify this, you will figure out that Y is equal to 3P. So this is equal to 3P. And this bottom area is 9P. So the total area of triangle ABC will be 12P, which is equal to 108, or the value of P will be equal to 9 square centimeters. Now if you are trying to understand, let me clear this off. If you are trying to understand why the ratio of the area of the smaller triangle and the bigger triangle is 1:4, if say this is a triangle, this is how the triangle is, and you join the midpoints of two sides. Now we know a lot of information about this. If this is A, this is B, and this is C, and this is D, and this is E. If say D and E are midpoints of B and C, these two are the same and these two are the same. Now a few things that you should know is that DE will be always parallel to BC, and the area of triangle ADE will be exactly 1/4 the area of triangle ABC, which is the larger triangle. Or trying to simplify this further, the area of triangle ADE will be 1/3 the trapezium, the bottom trapezium, which is DEBC. So if this is X, this will be 3X, and the area of triangle ABC will be 4X. In our earlier problem, we figured out that the area of this bottom trapezium is 9P. Therefore, the area of the top triangle is 3P, which is 1/3 of it. Therefore, the total area is 12P, which is given to us as 108. So the value of P will be 9 square centimeters. So the answer for this question is 9. In this question, we are told that there are three sides of a quadrilateral. They are given to be 1 centimeter, 2 centimeter, and 4 centimeter. We are asked to calculate what are the possible lengths of the fourth side if that is an integer, and these four make up a quadrilateral. If you have four sides of a quadrilateral such that A is less than or equal to, B is less than or equal to, C is less than or equal to D, the sum of the smallest three sides, A plus B plus C, has to be strictly greater than the largest side. Only then will the four lengths be part of the sides of a quadrilateral. If it is either equal or less than, then they cannot form a quadrilateral. So can the length of the fourth side be equal to 1 centimeter? In that case, the sum of these three will be 1 plus 1 plus 2, which is equal to 4 centimeters, which is the same as the length of the largest side. So that is not allowed, or 1 centimeter is not allowed. Can it be 2 centimeters? 1 centimeter is not allowed. If 2 centimeters, the sum of these two is 3 centimeters plus 2 is 5 centimeters, which is greater than 4 centimeters. So 2 centimeters is allowed. If you are looking at 3 centimeters, the sum of 1 plus 2 plus 3 is 6 centimeters, which is greater than 4 centimeters. So 3 centimeters is again allowed. If you are looking at 4 centimeters, the length of the fourth side is 4, then 1 plus 2 plus 4 is 7 centimeters, which is greater than 4 centimeters. So 4 centimeters is also allowed. If you are looking at 5 centimeters, then suddenly 5 centimeters, this is the unknown side becomes the largest side. The sum of the smallest three sides will be 1 plus 2 plus 4, which is 7 centimeters. 7 centimeters is greater than 5 centimeters, so this also is allowed. Similarly, the unknown side can even be 6 centimeters because the sum of the smallest three sides will remain 7 centimeters, so 6 centimeters will also be allowed. But the fourth side cannot be 7 centimeters or more because the sum of the three smallest sides in this particular case will remain 7 centimeters. So the fourth side cannot be 7 centimeters because then we will have the sum of the three smallest sides to be either equal to or less than the fourth side. That is not allowed. So the values that the fourth side can take, the integral values are 2, 3, 4, 5 and 6, which is 5. It can take 5 values. In this question, we are told that there is a triangle ABC, which is an isosceles triangle. Now, two sides are 8 centimeters each. This is told to us. This is A, this is B, and this is C. We are told that a circle is drawn with BC as diameter and this passes through A. Immediately, you should figure out that if there is a circle where you have a semicircle, you have a diameter, and you connect any point on the circumference to both ends of the diameter, that angle will be 90 degrees. That is, if you have any circle like this, you draw any diameter to this circle and connect any point on the circumference, the angle subtended at the circumference will be equal to 90 degrees. And this is vice versa also. That is, if there is a diameter and if there is any point which is a right angle, then that point has to lie on the circle. Now this would immediately tell you that ABC is a right angle triangle. AB is 8, AC is 8, this is given to us. So the length of BC, because this is a right angle triangle, will be 8 root 2, or the radius of this circle will be 4 root 2. This is the first circle. Let us call this circle to be C2. This is the smaller circle. Then we are told that there is another circle which is drawn with center A and this passes through B and C. The radius of this circle, it will be probably something like this. The radius of this circle, let us call this C1, is equal to 8 centimeters. This is because this circle has AB as the radius. We are required to calculate the area of the overlapping region between these two circles. This is the information that is given. We can now ignore the triangle ABC. The triangle ABC is only needed to figure out that this is the radius of the smaller circle is 4 root 2 and the radius of the larger circle is 8 centimeters. Let me clear all of this so that I will draw only two circles so that the explanation becomes easy. Let us assume this is the bigger circle and we have a smaller circle, something like this. Let us assume that this is passing through the center of the bigger circle. The radius of the bigger circle is 8 centimeters. The radius of the smaller circle is 4 root 2 centimeters. We are required to calculate the area of overlap. We know that the smaller circle is passing through the center of the bigger circle, which will be A. Now let this point over here be the center of the smaller circle. Let this be equal to say D. Now let us connect A to D. What is the length of AD? That will be the radius of the smaller circle, which will be 4 root 2. Let us connect D to the point of intersection of the two circles. This also will be 4 root 2. This also is a radius. If you are connecting A to the point of intersection, this will be 8 centimeters. Let this be equal to E. So this is 8 centimeters, this is 4 root 2 and this is 4 root 2. What does this tell us? This tells us that this is again a right angle because 4 root 2 square plus 4 root 2 whole square is equal to 8 square. So using Pythagoras formula, this is a right angle. Similarly, on the other side also, if you are connecting using the same logic, this also will be a right angle. This also is 4 root 2. Let this be F. We also know that ADE, this is a right angle isosceles triangle because it is the radius which is 4 root 2, that is two sides are equal. So this will be 45 degrees and this will be 45 degrees. In fact, if you really think about it, EF will be a straight line and O will be the midpoint of that. It doesn't look like a straight line, but it will be a straight line because we have 90 degrees and 90 degrees, which is 180 degrees over here. Let us ignore this. Now we need to calculate the area of overlap. So if you are again, just to make things more clear, if you are now drawing another circles which look something like this, just to remove the confusion, this is looking something like this. if you are joining both of them, the center of the smaller circle will lie on it. Why does that lie on it? Because we have realized that that angle is 90 degrees. If this angle is 90 degrees and this angle is 90 degrees, if the total angle of joining E and F is 180 degrees, it has to be a straight line. So it looks something like this. Now again, writing all of them, this is A, this is E, and this is F. This is the center of the circle. Now if you're trying to calculate the area of the overlap, we need to first calculate this area, the area of the shaded region. Once we calculate the area of the shaded region, if that is equal to A1, we can add the area of this semicircle to it to get the overall area of intersection. Calculating this area of the semicircle is very easy because we know that the radius of the smaller circle is 4√2. If this is D. So the area of semicircle is equal to 4√2 into 4√2 into pi divided by 2, because the area of the semicircle is pi r square divided by 2. √2 into √2 is equal to 2, which will cancel over here. So this is equal to 16 pi. Now if we can calculate the area of this shaded region over here, if you are calling that A1, the overall area of intersection will be A1 plus 16 pi. But what is A1? To calculate that, remember that this angle over here is 45 degrees, this angle over here is 45 degrees. So this itself, angle EAF, is 90 degrees. So let us first calculate the area of this sector. The area of this sector can be calculated because we know that this is 90 degrees and this radius of the bigger circle is 8 centimeters. So the area of the sector of the larger circle EAF will be equal to 1 by 4, because that is 90 degrees, 90 divided by 360 is 1 by 4, into pi r square, into pi into 8 into 8. This is equal to 16 pi. From that, remove the area of this triangle EAF. What is the area of the triangle EAF? ED is 4√2, DF is 4√2. So area of triangle EAF is equal to half into the base length is 8√2 into the height, or it is actually quite easy. This is a right angle triangle. We have two 8s, the base and the height. EA is 8 and FA is 8. This is a 90 degree right angle in the middle. So this is half into 8, which is equal to 32 centimeters square. So the area of this shaded region will be 16 pi minus 32. Add to that the area of the semicircle, that is another 16 pi. So the overall area of intersection will be 32 pi minus 32. Now this kind of a question you can even answer by looking at the options. How can you answer it by looking at the options? You should first figure out that the radius of the smaller circle is 4√2 and the radius of the larger circle is equal to 8. Once you figure it out, you know that what is the area of the smaller circle? Area of the smaller circle is 4√2 into 4√2 into pi. This is equal to 32 pi. The area of the smaller circle C2 is 32 pi. So the area of overlap, this area, will be definitely less than 32 pi. If it is definitely less than 32 pi, it cannot be option D. Now you figure out the area of this triangle. This triangle lies entirely within the area of intersection. And what is the area of this triangle? The area of this triangle, like we have just calculated, is 32. Now this kind of a question you can even answer by looking at the options. If you are looking at the options and if you figure out that this is 90 degrees over here, you are able to figure out that angle A is 90 degrees. Once you are able to figure out that angle A is 90 degrees, what is the area of triangle ABC? The area of triangle ABC we have calculated is 32 centimeters square. Now if you are trying to calculate what is the area of this sector, the area of this sector we have calculated is 16 pi. So intuitively, if you are able to figure out that required area, the area of overlap, has to lie between 32 pi, which is the area of the smaller circle. The area of the smaller circle is 32 pi. That is 4√2 into 4√2 pi, that is 32 pi. And you know that the area of this sector with this 90 degrees is 16 pi. So you know that it has to be greater than 16 pi and it has to be less than 32 pi. Once you figure that out, you know that it can't be option A. You know that it can't be option B, which is less than 16 pi. You know that it can't be option D because it is equal to 32 pi. The only option which lies between 16 pi and 32 pi is option C. So just by looking at the options also and thinking about it a little more, trying to figure out what the area will be, what is the range of that area, many times you can actually answer this question. In this question, we are told that the area of a regular hexagon is equal to the area of an equilateral triangle of side 12 centimeters. Let us assume that the side of the regular hexagon is S. If you know the side of a regular hexagon, what is its area? The formula for the area of a regular hexagon is given by 3 root 3 divided by 2 into S square. And what is the area of an equilateral triangle? When you know its length of each side, it will be equal to root 3 by 4 into A square. But here the value of A is 12. So if you are equating both of them, 3 root 3 by 2 into S square is equal to root 3 by 4 into 12 into 12. We can cancel root 3 on both sides. We can cancel 3 because 12 by 4 is 3. So the value of S square is equal to 12 into 2, which is 24. Or the value of S is square root of 24 centimeters. Square root of 24 is equal to 2 into square root of 6 centimeters. So the correct answer is option D. In this question, we are told that suppose the length of each side of a regular hexagon ABCDEF is 2 centimeters. So let us assume that this is how the hexagon is. This is AB, this is BC, this is CD, this is DE, this is EF, and this is FA. This is A, this is B, this is C, this is D, this is E, and this is F. Each side of this regular hexagon is 2 centimeters. So this is 2 centimeters, this is 2 centimeters, and this is 2 centimeters, and so on. We are told that T is the midpoint of CD. So T is over here. So the length of CT will be 1 centimeter, and the length of TD will be 1 centimeter. We are asked to calculate the length of AT. So let us first connect A to T. And we are asked to calculate the length of AT. To calculate the length of AT, let us first calculate the length of AC. Once we calculate the length of AC, calculating the length of AT will be quite easy. We will see why. The first thing we should notice is that every angle in a regular hexagon will be equal to 120 degrees. So now if you are looking at the triangle ABC, we know two sides. The lengths of both the sides are 2 centimeters and 2 centimeters, and the angle between them is 120 degrees. So if you assume that the length of AC is x, using the cosine rule, x square will be equal to 2 square plus 2 square, that is the sum of the squares of the remaining two sides, minus 2 times the product of the two sides, which is 2 into 2 into cos of the angle between them, which is cos 120 degrees. This is equal to 2 square is 4 plus another 2 square is 4. Cos 120 degrees is minus 1 by 2. So this becomes equal to plus 2 into 2 into 2 into 1 by 2. This is another 4. Or x square is equal to square root of x is equal to square root of 12, because x square is equal to 12. So the length of AC is 12, square root of 12 centimeters. We know that angle ABC is 120 degrees. So angle BAC will be 30 degrees and angle BCA will also be equal to 30 degrees. What this is going to tell us is that now the angle ACD will be 90 degrees. Because the angle BCD is the interior angle of a regular hexagon, which will be equal to 120 degrees. If you are removing 30 degrees from it, the remaining angle will be 90 degrees. So now triangle ACT is a right angle triangle. One of the side is square root of 12 centimeters. Another side is 1 centimeter, which is CT. AT is the hypotenuse. So AT square will be square root of 12 whole square, which is 12, plus 1 square, which is 1. So this is equal to 13. So the length of AT will be equal to square root of 13 centimeters. So the correct answer is option A. In this question, we are told that there is a circle of diameter 8 inches, that is the radius of the circle is 4 inches. This can be inscribed in a right angle triangle where one of the angles is 90 degrees. So let us first draw the triangle. So let us assume that this is the triangle. B is the right angle, this is A and this is C. We are told that one of the sides is 10 inches, so this is 10 and the in radius is 4 inches. This is the information that is given to us. We are asked to calculate the area of the triangle. In the right angle triangle, if you assume that the two sides, the two non-hypotenuse sides are A and B and the hypotenuse is equal to C, then the in radius is equal to A plus B minus C divided by 2. And the circumradius, although this is not important for this question, the circumradius of a right angle triangle is C by 2. That is, it is half the length of the hypotenuse. In this case, let us assume that the length of AB is small a and the length of AC is B is equal to C. Then we know that A plus 10 minus C divided by 2 is the in radius, which is equal to 4. Or this would imply that A plus 10 minus C is equal to 8, or the value of C is equal to A plus 2. This is a right angle triangle, so the squares of the non-hypotenuse sides, when you sum them up, will equal the length of the hypotenuse whole squared, or essentially C square is equal to A square plus 100, which is 10 square, but C square is equal to A plus 2 whole square. So that will be A square plus 4A plus 4 is equal to A square plus 100. We can cancel A square on both sides. So the value of A plus 1 is equal to 25, or the value of A is equal to 24. So this is 24 inches and the hypotenuse is 26 inches. Now the area of this right angle triangle will be half into base into height. So that is half into 24 into 10, which is equal to 120 square inches. That will be the answer.
We at Kraku provide all the previous year CAT papers along with many other MBA examinations such as IIFT, XAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.
In this question, we are told that a rhombus has an area of 12 square centimeters and a side length of 5 centimeters. We are asked to calculate the length in centimeters of its longer diagonal. So let us assume that the rhombus is something like this. Now, a few things you should know about a rhombus is that the diagonals of a rhombus intersect each other at right angles. So if you are drawing the two diagonals like this, both of them intersect each other at right angles, so they will be perpendicular to each other. Let us assume that the rhombus is A, B, C and D and they intersect at a point O. Let us assume that the longer diagonal is say BD. So let us assume that DO is B and BO is also small b. Let us assume that AO is small a and CO is small a. We know that the side of each side of the rhombus is 5 centimeters. So if you are looking at any of the triangles AOB or BOC or COD or DOA, all of them are right angle triangles. So using Pythagoras theorem, A square plus B square will be equal to 5 square, which is 25. We are given the area of the rhombus. The area of the rhombus is 12 square centimeters. What does this mean? The area of a rhombus is the product of the diagonals divided by 2. Each of the diagonals over here is 2A and the other one is 2B. So this is the product of the diagonals. You divide it by 2 and then you will get the area of the rhombus. So this would imply that this is equal to 12, or the value of A into B is equal to 6. We are given A square plus B square. We are given the product of A into B. So we can calculate the value of A and B. How are we going to do that? We know that A square plus B square plus 2AB will be equal to 25 plus 12, which is 37, and A square plus B square minus 2AB is equal to 25 minus 12, which is equal to 13, or the value of A plus B is equal to square root of 37, and the value of A minus B, if you are assuming that A is greater than B, is equal to square root of 13. So the value of 2A, if you are adding both of them, will be equal to square root of 37 plus square root of 13. Remember that the area of the diagonal is 2A. The area of half of the diagonal is A, but the area of the diagonal is A plus A, which is 2A, and the area of the length of the diagonal is 2A. Similarly, the length of the other diagonal is B plus B, which is 2B. So the length of the longer diagonal will be square root of 37 plus square root of 13, which is option A. In this question, we are told that the sides AB and CD of a trapezium are parallel, with AB being the smaller side. So let us assume that the trapezium is something like this. This is AB and this is CD. This is A, B, C and D. We are told that P is the midpoint of CD. So let us assume that this is P. And ABPD is a parallelogram. So if you are drawing this, ABPD is a parallelogram. In a parallelogram, the parallel sides are equal. So if you assume that the length of AB is small a, the length of DP will be small a, and because P is the midpoint of CD, the length of CP will also be equal to small a. Now if you assume that the height of the trapezium, that is if you are drawing a perpendicular from AB to CD, if this height is equal to H, then what is the area of the parallelogram ABPD? The area of the parallelogram is basically the length of the parallel sides into the perpendicular distance between them. So in this particular case, the area of the parallelogram ABPD will be equal to A into H. Similarly, what is the area of the triangle BPC? The area of the triangle BPC is the base into height divided by 2, which is equal to A into H divided by 2. So the difference between the area of the parallelogram and the area of the triangle will be AH minus AH by 2, which is AH by 2. But this difference is given to us. We are told that that is equal to 10 square centimeters. Or the value of AH will be equal to 20 square centimeters. Now, what is the area of the trapezium? Area of the trapezium is the area of the parallelogram plus the area of the triangle, which is AH plus AH by 2, which is equal to 3AH by 2. If AH is equal to 20, what is the value of 3AH by 2? That will be 3 into 20 divided by 2, which is equal to 30 square centimeters. So the correct answer is option A. In this question, we are told that D and E are points on the sides AB and AC of a triangle ABC. So let us assume that this is the triangle ABC. This is A, this is B and this is C. We are told that D and E are points such that AD is to BD is 2:1. So let us assume that AD is 2x and BD is x. Similarly, E is a point on AC such that AE is to CE is 2:3. So let us assume that this is 2y and this is 3y. We are given the area of triangle ADE. We know that in any triangle ABC, if you have given a triangle like this, say the triangle's name is PQR, just to avoid any confusion. And suppose the length of the sides opposite each of these angles is small p, small q and small r. Then what is the area of this triangle PQR? It is equal to half into p into q into sin r, which will equal half into r into q into sin p, which will also equal half into r into p into sin q. Basically the product of two sides, you multiply it with the sine of the angle between both of them and divide it by 2. That will be the area of a triangle. In this particular case, what is the area of triangle ADE? The area of triangle ADE will be equal to half into AD, which is equal to 2x, into AE, which is equal to 2y, into sin A. But we are given that this area is equal to 8. So 8 is equal to 2xy into sin A, or the value of xy into sin A is equal to 4. This is the information that is given to us. We are asked to calculate the area of triangle ABC. What is the area of triangle ABC? That is equal to half into AB, which is equal to 3x, into AC, which is equal to 5y, into sin A. So this is equal to 15 by 2 into xy sin A. We know that xy sin A is equal to 4. So the area of triangle ABC will be 15 by 2 into 4, which is equal to 30 square centimeters. In this question, we are told that the cost of fencing a rectangular plot is 200 per feet for one side and 100 per feet for the remaining three sides. So if you assume that this is how the rectangle is, for one of the sides it is 200 per feet and for the remaining ones it is 100 per feet. Let us assume that the length and the breadth is say L and B. So what is the total money that it is going to cost to fence the entire perimeter of the rectangle? This will be 200 L for this side plus 100 B for this side plus 100 L for this side plus 100 B for this side. So the total cost will be 300 L plus 200 B. But we are given the area of the rectangle. We are told that the area is 60,000 square feet. So the product of L into B is given to be equal to 60,000. Now we are required to minimize the cost. What should be the value of L and B be such that the cost is minimized, and we are required to calculate that lowest possible cost. We can use arithmetic mean is greater than or equal to geometric mean. We know that 300 L plus 200 B divided by 2 is greater than or equal to square root of 300 L into 200 B. 300 into 200, this is 60,000. And L into B we were given is also equal to 60,000. So the right hand side of the inequality is square root of 60,000 into 60,000, which is basically equal to 60,000. So 300 L plus 200 B by 2 is greater than or equal to 60,000, or the value of 300 L plus 200 B, the minimum possible value is 1.2 lakhs, which is 2 times 60,000. In this question, we are told that there is a rhombus. The area of the rhombus is 96 square meters and 40 meters fencing is required to enclose the park. 40 meter is the perimeter of a rhombus. In a rhombus, all the sides are equal. So each of the four sides has to equal 10 meters. So let us draw the rhombus. Let us assume that this is the rhombus. Let us assume that this is the rhombus. Let us draw the diagonals of the rhombus also. This is one diagonal and this is the second diagonal. In a rhombus, the diagonals intersect at 90 degrees with each other. The diagonals are basically perpendicular to each other. Let us assume that this is the rhombus A, B, C and D. As the perimeter is 40 meters, each of the side has to be 10 meters. So this is 10, this is 10, this is 10 and this is 10. Let us assume that the diagonals are of length 2A and 2B, just to make the calculations easy. So the length of one diagonal is 2A and the length of the other diagonal is 2B. Now we know that the area of a rhombus is the product of the diagonals divided by 2. In this particular case, one diagonal is 2A and another diagonal is 2B. So 2A into 2B divided by 2 is equal to 96, or the value of A into B is equal to 48. We also know that because they are intersecting at right angles, each of these is a right angle triangle. If you are looking at AOB, for example, A and B are the non-hypotenuse sides and 10 is the hypotenuse. So A square plus B square is equal to 100. Using this, we can calculate the length of A and B. How can you calculate that? We can add 2AB and we can calculate A plus B, and we can subtract 2AB and we can calculate A minus B. Or you can look at this equation and figure out that one of them has to be 8 and the other has to be 6. If you are trying to actually derive it, because AB is equal to 48, 2AB will be 96. If you are adding A square plus B square to 2AB, you are going to get A plus B whole square. This will be equal to 100 plus 96, which is 196. So A plus B is equal to 14, which is the square root of 96. Similarly, if you subtract 2AB from A square plus B square, you are going to get A minus B whole square, and that is going to equal 100 minus 96, which is equal to 4. So A minus B is equal to 2, or the value of A will be 8, because 14 plus 2 is 16, 16 is equal to 2A. Similarly, B will be equal to 14 minus 2 divided by 2, which is 6, like we expected. But this is half of the diagonals. The lengths of the diagonals are 2A and 2B. So the lengths of both the diagonals are 16 and 12. So if you are trying to lay electric wires along the two diagonals, the total distance will be 16 plus 12, which is equal to 28, and the cost is 125 per meter, so it is 28 into 125. 28 into 125 is 3500. That will be the total cost. In this question, we are told that there is a triangle ABC in which one of the angles BCA is given to be equal to 50 degrees. So let us draw the triangle. Let us assume that this is how the triangle looks. This is A, this is B, and this is C. We are told that angle C is 50 degrees. We are told that D and E are points on AB and AC. So let us assume that this is D and this is E, such that AD is equal to DE. So if you join D and D, these two sides are of the same length. We are told that F is a point on BC, so F is somewhere over here, such that BD is equal to DF. So again, if you join D and F, BD and DF are the same. So here we are having a lot of isosceles triangles. So if you are first looking at the isosceles triangle ADE, and if you assume that angle A is small a, then the value of angle E will also be equal to small a, because AD is equal to DE. Similarly, BDF is an isosceles triangle. So if you assume that angle B is small b, the value of angle F will also be equal to small b. So what is the value of angle BDF? This will be 180 minus 2b. Similarly, the value of angle ADE will be 180 minus 2a. Now we can calculate the value of angle FDE, because the value of angle BDE plus angle FDE, angle BDF plus FDE plus EDA, the sum of these three angles has to equal 180 degrees because they are lying on a straight line. This would imply that the value of angle FDE will be equal to 180 minus 2a plus 180 minus 2b. Or if you simplify this, this is equal to 2a plus 2b minus 180 degrees. But do we know the value of a plus b? We know that angle A plus angle B plus 50 degrees has to equal 180 degrees because ABC is a triangle. So A plus B plus 50 degrees is equal to 180 degrees, or the value of A plus B is equal to 130 degrees. So the value of 2 times A plus B minus 180 will equal 2 times 130 minus 180, which is equal to 260 minus 180, which is equal to 80 degrees. So the answer for this question is option B, which is 80 degrees. In this question, we are told that ABCD is a parallelogram and the length of AD and the length of the diagonal AC are given 10 centimeters and 20 centimeters. We are also given the angle ADC, this is equal to 30 degrees. We are asked to calculate the area of the parallelogram. Let us first understand the information that is given to us. We have A, B, C, D. This is the parallelogram. We are given A, B, C and D. We are given the length of AD, this is 10 centimeters. We are told that the length of the diagonal AC is 20. So this is 20. And we are told that the angle ADC over here is 30 degrees. Let us drop a perpendicular from A to CD. Let us assume that this is meeting CD at a point E. Now the area of the parallelogram is basically the length of DC into the height AE. So if you are able to figure out the length of CD into the height AE, that is the area. That is what we are required to find out. Now if you look at 30 degrees and you have 10, so if you are looking at the triangle AED, that is a right angle triangle, so the length of ED can be determined. That will be equal to 10 cos 30 degrees. So what is the length of AE? This will be 10 sin 30 degrees. Therefore, the length of AE, because sin 30 is half, AE will be equal to 5. And the length of DE will be equal to 5 root 3. So we have figured out the length of AE. We have to figure out the length of CD. If you are trying to figure out the length of CD, we have already figured out the length of ED. So if we can figure out the length of EC, we will be done. How can we figure out the length of EC? If you are looking at the triangle AEC, that is a right angle triangle. We know that the length of the hypotenuse is 20. We know that the length of one of the non-hypotenuse sides is 5. So the length of EC will be square root of 20 square minus 5 square. 20 square is 400. So this is equal to square root of 400 minus 25, which is equal to square root of 375. If you divide 375 by 25, that will be equal to 15, because 25 into 15 is equal to 375. So this is equal to 5 square root of 15. Therefore, the length of CD will be 5 square root of 15 plus 5 square root of 3, because 5 square root of 15 is EC and 5 square root of 3 is ED. So the length of CD is 5 square root of 15 plus 5 square root of 3. The length of AE is 5. Therefore, the area of the parallelogram will be 25 into square root of 3 plus square root of 15. So the correct answer is option B. In this question, we are told that there is a solid right circular cone and the height of the cone is 27 centimeters, and this was cut into two pieces along the plane which is parallel to its base at a height of 18 centimeters from the base. So let us look at the cone. So say this is the cone in 2 dimensions. The height of this cone is given to us as equal to 27 centimeters. So let us draw a line from the apex to the base. This height is equal to 27 centimeters. Now it was cut into two parts from at a height of 18 centimeters from the base. So if you draw another line which is perpendicular to the base, and let us name the triangle, say this is A, this is B, this is C, and this is D, and say this is E. The length of ED is given as equal to 18 centimeters. Therefore, what is the length of AE? This will equal 9 centimeters. We are told that the volume of the two pieces which are so formed, the difference between those volumes is 225 cc, and we are required to calculate the volume of the original cone. So we know that the height of the original cone is 27 centimeters. Let us assume that the initial radius of the cone is say 3r. So the length of DC, this will equal 3r. So if you consider the two triangles AE, say F, this is similar to the triangle ADC, because all the angles will be the same. Angle A is common and EF is parallel to BC. So all the angles, that is AEF, will be same as ADC and AFE will be same as ACD. So as all the angles are the same, all the sides will be in the exact same proportion. So AE divided by AD will equal EF divided by DC. AE we know is equal to 9 centimeters and AD is equal to 27 centimeters. So this is equal to 1 by 3. We know that the length of DC is equal to 3r. Therefore, the length of EF, which is the radius of the smaller cone, will equal small r. So the height of the original cone is 27 centimeters. Radius of the original cone is 3r. Height of the smaller cone is equal to 9 centimeters and radius of the smaller cone is r. So what is the volume of the smaller cone? That will be equal to pi by 3 into r square into h. This is the volume of the smaller cone. Let us assume that this is equal to V1. And what is the volume of the original cone, the bigger one? This is equal to pi by 3 into r square. So this is 3r whole square, which will equal 9r square, into h, which is equal to 27. So if you look at it, pi by 3 into 9r square is exactly equal to V1, or the volume of the original cone is equal to 27 times V1. So what is the volume of the frustum, that is the bottom part? This will equal 26 V1. The smaller cone, the new cone that is formed, is equal to V1, and the overall volume of the original cone is 27 V1. We are told that the difference between 26 V1 and V1, that is 25 V1, is given to be equal to 225, or V1 is equal to 9. So what is the volume of the original cone, which is equal to 27 V1? That will equal 27 into 9, which is equal to 243. So the correct answer is 243 cc. In this question, it is given that there is a rectangular metal sheet of area 135 square inches and a circle is painted in it such that the circle touches two of the opposite sides. So let us first draw a rectangle, and let us also draw a circle which touches the opposite sides. So it will be something like this. Now what is told to us is that the area of the sheet that is left unpainted, that is the area of the rectangular sheet which is not part of the circle, is 2/3 the area of the painted area. So let us assume that the area of the circle is A, then the area of the unpainted area is 2/3A. So what is the area of the entire rectangle? That will be A plus 2/3A, which is equal to 5/3A. But we are already given the area of the rectangular sheet, that is equal to 135 square inches. So this is equal to 135 square inches, or the value of A is equal to 27 into 3, which is equal to 81 square inches. So let us assume that the radius of the circle is equal to R. Say this is equal to R. Then what is the area of the circle? That will equal pi R square. So pi R square is equal to 81, or the value of R is equal to square root of 81 by pi, which is equal to 9 by square root of pi. Now we are required to calculate the perimeter of the rectangle. As we know the value of R, we know the breadth of the rectangle, which will equal 2R. So this is equal to 18 by square root of pi. And we can calculate the length of the rectangle because we know the area of the rectangle, which is equal to 135 square inch. So if you assume that the length of the rectangle is L into 2R, that is L into 18 by square root of pi is equal to 135. Or this, you can cancel 9 on both sides, this will equal 2 and this will equal 15. The value of L is equal to 15 square root of pi by 2. We are required to calculate the perimeter of the rectangle. Perimeter of the rectangle is 2 times length plus breadth. The value of the breadth is 18 by square root of pi, and the value of the length is 15 into square root of pi divided by 2. So if you sum them up, L plus B will equal 15 by 2 into square root of pi plus 18 by square root of pi. This you have to multiply by 2 to get the perimeter. This will equal 36 by square root of pi plus 15 square root of pi. Or you can take 3 square root of pi common, and this will equal 5 plus 12 by pi. So the perimeter of the rectangle is 3 into square root of pi into 5 plus 12 divided by pi. In this question it is given that there is a circle which is inscribed in a rhombus, and the lengths of the diagonals of the rhombus are given. They are 12 centimeters and 16 centimeters. So let us assume that the rhombus and the circle are as given in the diagram. We know the lengths of both the diagonals also. The diagonals are 12 centimeters and 16 centimeters long. One of the things that we should notice is that in a rhombus, the diagonals will be perpendicular to each other. So both of them will be perpendicular to each other, and they will also bisect each other. So if the diagonal is 12 centimeters, and if you are naming the rhombus as A, B, C and D, and the point of intersection of the diagonals as O, as we know that the length of AC is equal to 12 centimeters, the length of AO will be 6 centimeters, and the length of OC will also be equal to 6 centimeters. Similarly, the length of OB will be equal to 8 centimeters, and the length of OD will also be equal to 8 centimeters. Now if you are considering triangle ABO, it is a right angle triangle in which one side is 6 and the other side is 8. So we can easily calculate the length of the hypotenuse AB. The length of the hypotenuse AB will be equal to square root of 6 square plus 8 square, which is equal to square root of 36 plus 64, which is equal to square root of 100. This is equal to 10 centimeters. So the length of AB will be equal to 10 centimeters. Now let us also connect the center of the circle O to the point of intersection, or the point of where the tangent AB meets the circle. Let us call this point equal to say Q, and let the length of AQ be equal to small a, and the length of BQ be equal to small b, and let the radius of the circle, that is OQ, be equal to R. Now what do we know? Because we know that the length of AB is equal to 10 centimeters, the length of A plus B is equal to 10. Also, as AB is a tangent to the circle, even the angle AQO and the angle BQO will also be equal to 90 degrees. Therefore, we know that A square plus R square is equal to 6 square. because triangle AQO is a right angle triangle. Similarly, B square plus R square is equal to 8 square, because again triangle BQO is also a right angle triangle. Or if you subtract one equation from the other equation, we get that B square minus A square is equal to 8 square minus 6 square, which is equal to, what is 8 square? That is equal to 64 minus 36, which is equal to 28. B square minus A square is basically equal to B minus A into B plus A. This is equal to 28. We know that A plus B is equal to 10. So this will equal 10, or the value of B minus A is equal to 28 divided by 10, which is equal to 2.8. We know that A plus B is equal to 10, and we know that B minus A is equal to 2.8. So we can figure out that the value of B is equal to 10 plus 2.8, which is 12.8 divided by 2, which is equal to 6.4 centimeters. Now we can easily calculate the radius R, because R square is equal to 8 square minus 6.4 square, which is equal to, again this is of the form A square minus B square, so this will be 8 plus 6.4, which is 14.4 into 1.6. We can calculate the value, but it is not really needed, because we are only looking for the area of the circle. What is the area of the circle? That is equal to pi R square. So that will equal pi into 14.4 into 1.6. And what is the area of the rhombus? Because we know the length of the sides of the diagonals of the rhombus, which is equal to 16 and 12. The area of the rhombus is 16 into 12 divided by 2, because the area of a rhombus is the product of the lengths of its diagonals divided by 2. So this will equal, this is 8, so 12 into 8 is 96. So the required ratio is pi into 14.4 into 1.6 divided by 96. We can simplify this. 96 divided by 1.6 is equal to 60, or this will equal pi into 144 divided by 600. We can divide the entire equation by 6, so this will equal 24 and this will equal 100. Now we can divide the entire equation by 4, so this will equal 6 and this will equal 25. Or the required ratio is 6 pi divided by 25. So the correct answer is option A.
Google search Krakow free CAT mock. Click on the first link. You can attempt a free mock test which was attempted by 30,000 CAT aspirants in the actual exam format. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solution to get video solutions from our expert faculty.
In this question, we are given 2 points, 2, 1 and minus 3, minus 4, and we are told that these are opposite vertices of a parallelogram. So in a parallelogram, you have two sides which are, the opposite sides are parallel to each other. So this is a parallelogram, and we are told that we have been given the one set of opposite vertices. We are told that this is equal to 2, 1 and this is equal to minus 3, minus 4. We are also told that the other two vertices lie on the line x plus 9y plus c is equal to 0. So let us first connect both the opposite vertices. So these are the diagonals of the parallelogram, and we have been told that this line is x plus 9y plus c is equal to 0, and we are required to calculate the value of c. So both the opposite vertices, if you are calling them to be a, b, c and d, they A and C lie on the line x plus 9y plus c is equal to 0. So does the point of intersection of both the diagonals, that is say is equal to O. But we know the coordinates of O. O is the midpoint of B and D. So the coordinates of O will be 2 plus minus 3, that is 2 minus 3 by 2, which is minus 1 by 2. And the y coordinate will be 1 minus 4 divided by 2, which is equal to minus 3 by 2. So even O lies on the line x plus 9y plus c is equal to 0. Or if you substitute the coordinates of O in the given line, it should equal 0. That is, the x coordinate is minus half plus 9 times the y coordinate is minus 3 by 2 plus c is equal to 0, or the value of c is equal to half plus 27 by 2, which is equal to 28 by 2, which is equal to 14. So the value of c is 14. In this question, we are told that there is a trapezium ABCD such that AB is parallel to DC and BC is perpendicular to DC. We are also given the angle BAD is equal to 45 degrees. We are told that DC is equal to 5 centimeters, BC is equal to 4 centimeters, and we are asked to find out the area of the trapezium. So let us first draw the trapezium. Let us assume that this is AB, this is BC, BC is parallel to DC, so DC will, this is D, and we will get DC something like this, which is perpendicular. And we also are told that angle BAD is equal to 45 degrees. So it will look something like this. This is the trapezium A, B, C and D. BC is perpendicular to DC. Angle BAD is equal to 45 degrees. So this is equal to 45 degrees. We are told that DC is equal to 5 centimeters. So this is 5 centimeters. BC is equal to 4 centimeters. So this is 4 centimeters. And we are asked to calculate the area of this trapezium. In order to calculate the area of a trapezium, you need the length of the parallel sides. You know the length of DC, but you don't know the length of AB. Once you know the length of AB, you will have to take the average of both the parallel sides, that is AB plus DC, and then multiply it with the height of the trapezium. Height is again known, this is equal to 4 centimeters. That is the length of BC. But how do we calculate the length of AB? Let us draw a perpendicular from D to AB. Let us assume that it meets AB at a point E. So DA is equal to 4 centimeters. DA will be the same as BC. So this is equal to 4 centimeters. This is a right angle triangle. So angle ADE will also equal 45 degrees. Or this is a right angled isosceles triangle. So AE will equal DE. So the length of AE will also be equal to 4 centimeters. The length of BE will be equal to the length of DC, which is equal to 5 centimeters. Or the length of AB will be equal to 9 centimeters. The length of DC we know is equal to 5 centimeters. So their average will be half of 9 plus 5, that is half of 14, which is 7 centimeters. Into the height of the trapezium is 4 centimeters. So the area of the trapezium is equal to 28 centimeters square. In this question, we are given the vertices of a triangle and we are asked to find out the area of the circle that is passing through these 3 points. Let us first plot the triangle on a graph. This is the y-axis and this is the x-axis. One of the points is 0, 0, which is the origin. The other point is 4, 0, which lies on the x-axis. So this is 4, 0. And the third point is 3, 9. So it will be somewhere over here. Let us draw the 3 sides of the triangle also so that we can understand this better. This is one side, the x-axis is the second side, and this is the third side. From the looks of it, this is not any triangle with any special properties. That is, this is not a right angle triangle or an equilateral triangle. This is just 3 sides, 3 vertices that are given to us. Let us call the 3 vertices A, B and C. So how can we find out the area of the circle which is passing through these 3 points? For that, we will have to calculate the circumradius. The circle which is passing through all the 3 vertices is the circumcircle. So if we can find out its radius, we can easily calculate its area. Once we calculate the value of r, the area of the circle will be pi r square. Now there are many ways in which we can calculate the circumradius of a given triangle. In this particular case, the formula to use, which will make it very easy, is that r is equal to a into b into c divided by 4a, where a, b and c are the 3 sides of the triangle and a is the area of the triangle. Let us first calculate the area of this triangle. In this triangle, if we draw a perpendicular from a to bc, the length of this line will be quite easy to calculate. This is the y coordinate of a, which is equal to 9 units. So the height of the triangle is 9 units and the length of the base, which is equal to BC, is equal to 4 units. So what is the area of this triangle? It will be half into height, which is 9, into base, which is 4. This is equal to half into 36, which is equal to 18 units. So the area A is equal to 18 units. We know the length of BC, that is the value of small a is equal to 4 units. That is the distance between 0, 0 and 4, 0. That will equal 4 units. What is the length of B? The length of B is the length of AC. We know the vertices of both the coordinates, so we will have to calculate its length. If you are given 2 coordinates x1, y1 and x2, y2, the distance between these 2 points is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So in this particular case, the length of B will equal square root of 3 minus 4 whole square, which is equal to 1 square, plus 9 minus 0 whole square, which is equal to 9 square. This is equal to square root of 81 plus 1, which is equal to square root of 82. Similarly, the length of C, which is the length of AB, will equal, using the same formula, 3 minus 0 whole square, which is equal to 3 square, plus 9 minus 0 whole square, which is equal to 9 square. This is equal to square root of 81 plus 9, which is equal to square root of 90. Now we know the length of A, B and C, and we know the area of the triangle, so we can calculate its circumradius. So the value of R will equal 4 into, what is the value of B? Square root of 82 into C is square root of 90 divided by 4 times area. Area we have calculated is equal to 18. So we can cancel 4 on both sides. Square root of 90 is equal to, square root of 90 will be 3 into square root of 10 and into square root of 82 divided by 18. So this will be 6. You can cancel 3 in the numerator. From square root of 10 we can take a square root of 2 out. From square root of 82 we can take a square root of 2 out, or essentially this will become equal to the numerator 2 into square root of 5 into square root of 41 by 6. So this will be 3, and you can cancel 2 also in the numerator. So this will equal square root of 205 divided by 3. This is the circumradius of the triangle. So what is the area of the circle? That will be pi r square, as we have discussed earlier, which will be equal to pi into square root of 205 whole square, which is 205, divided by 3 square, which is equal to 9. So the correct answer will be 205 pi by 9, which is option D. In this question, it is given that C is a circle and the radius of the circle is 5 meters and it has a center at O. So let us assume that this is the circle C and let the center be over here. This is O. We are told that PQ is a chord of C such that it passes through 2 points A and B. A is located 4 meters north of O. So let us assume that this is somewhere over here. This is A and this is B. We are told that AO, if you connect A to O, this is 4 meters, and if you connect O to B, this is perpendicular because one of them is in the east direction and one of them is in the north direction, and this is equal to 3 meters and this is equal to 4 meters. This is A and this is B. If you extend AB such that they meet the circle, they will meet the circle at points P and Q. So it will be something like this. Now what we are supposed to calculate is the length of PQ. So to calculate the length of PQ, or basically the length of a chord, if we can identify the distance of the chord from the center, we can easily identify the length of the chord because we know the radius of the circle. So let us first join or draw a perpendicular from O to the chord AB, to the chord PQ, and let us assume that it touches the line at a point. Let us say this is equal to D. Now let us assume that AD is equal to small a and let us assume that BD is equal to small b. Because the lines AO and BO are perpendicular to each other and their lengths are equal to 3 and 4, they are part of a right angle triangle, and therefore the length of AB, which is equal to small a plus b, will equal square root of 3 square plus 4 square, because this is a right angle triangle, and that will equal 5, or the value of a plus b is equal to 5. Let us assume that the length of OD, which is the perpendicular from O to AB, is equal to small d. So again a square plus d square is equal to 4 square, and b square plus d square is equal to 3 square. Now we can subtract one equation from the other. Therefore a square minus b square is equal to 4 square minus 3 square, that is 16 minus 9, which is equal to 7. A square minus b square is equal to a minus b into a plus b. This is equal to 7. We already know that a plus b is equal to 5. So the value of a minus b will equal 7 divided by 5, which is equal to 1.4. So again a plus b is equal to 5 and a minus b is equal to 1.4. So the value of a is equal to 5 plus 1.4, that is 6.4 divided by 2, which is equal to 3.2. Using this we can calculate the length of d square, or the length of d square will equal 4 square minus a square. So that is 16 minus 3.2 whole square. 3.2 whole square is 10.24. So this is equal to 5.76. This is the length of d square. So using this we can calculate the length of the chord PQ. How are we going to do that? Suppose we just have a circle and we know that there is a chord PQ over here, and you draw a perpendicular from the center to the chord, we know the radius of the circle. This is given to us as equal to 5 and the perpendicular is equal to D. So if you assume that this is P, this is Q and this is D and this is O, so the length of PD square is equal to phi square minus D square. What is the length of phi square? This is equal to 25 minus D square is 5.76. So this is equal to 19.24, or the length of PD will be equal to the square root of 19.24, which will be approximately equal to 4.4. So PD is equal to 4.4. Similarly, QD will also equal 4.4, or the length of PQ will be 2 into 4.4, which is approximately equal to 8.8. So the correct answer is option A. In this question, we are told that the sum of the perimeters of an equilateral triangle and a rectangle is 90 centimeters. So we have an equilateral triangle, something like this, and we have a rectangle. Let us assume that it is like this. We are told that the sum of these two perimeters is 90 centimeters. We are also told that the area of the triangle, if it is considered to be T, and the area of the rectangle, if it is equal to R, share the relationship R is equal to T square. We are also told that the sides of the rectangle are in the ratio 1:3. So let us assume that the sides of the rectangle are B and 3B. This is 3B, this is 3B, and this is B. And let us assume that each side of the equilateral triangle is say small a. So this is A and A. Now we are required to find out the length of the longer side of the rectangle. That is, we are required to calculate what is the value of 3B. We are given one relationship. We are told that the areas of the rectangle will be equal to 3B into B, so that is equal to 3B square. This is the value of R. This is equal to T square. What is the area of the triangle? That is equal to root 3 by 4 A square. This is the value of T, but because R is equal to T square, that would imply that 3B square is equal to root 3 by 4 A square into root 3 by 4 A square. We can cancel 3 on both sides because root 3 into root 3 is equal to 3, or B square is equal to A square by 4 into A square by 4, or the value of B is equal to A square by 4, or the value of A is equal to 2 square root of B. We are given the sum of the perimeters of both the triangle and the rectangle. What is the perimeter of the equilateral triangle? This will equal 3A. And what is the perimeter of the rectangle? This will equal 3B plus B, that is 4B, plus 3B plus B, so that is another 4B, or that will equal 8B. So we know that 3A plus 8B is equal to 90 centimeters, or we can substitute instead of A 2 square root of B. So this would imply that 8B plus 6 square root of B is equal to 90. Just for ease of calculation, let us assume that square root of B is equal to x, or the value of B is equal to x square. So this equation can be transformed to equal 8x square plus 6x minus 90 is equal to 0. This is a quadratic equation. We can divide the quadratic equation by 2 because all the coefficients are even numbers. So this would imply that 4x square plus 3x minus 45 is equal to 0. Or if you are factorizing this, 4x square plus 15x minus 12x minus 45 is equal to 0, or x minus 3 into 4x plus 15 is equal to 0. So the value of x is equal to 3. The second value of x, which is equal to minus 15 by 4, is not allowed because x has to be a positive number. So if x is equal to 3, what is the value of b? The value of b will equal x square, which is equal to 9. So the length of the sides of the rectangle are 9 and 27. This is also 9 and 27. And the sides of the equilateral triangle A will equal 2 into square root of B, or 2 into 3, that is equal to 6. So this is 6, 6 and 6. What we are required to find out is the value of 3B, which is the length of the longer side of the rectangle, which will equal 27. In this question, we are told that C1 and C2 are concentric circles such that the diameter of C1 is 2 centimeters longer than that of C2. So let us first draw two concentric circles. This is the smaller circle, so let us assume that this is C2, and this is the larger circle, so let us assume that this is C1. So we have this to be equal to C2 and the larger circle to be equal to C1. the diameter of C1 is 2 centimeters longer than the diameter of C2. So if you assume that the radius of C2 is equal to R, then the radius of C1 will equal R plus 1. Because if diameter is 2 centimeters long, radius will be 1 centimeter long. We are also told that if you draw a tangent to C2, if you draw a chord of C2 which such that it is a tangent to C1, and if the length of the chord of C1 is 6 centimeters, this is tangent to C2, we are required to calculate the diameter of C1. So let us name some points. Let the center of both the circles be equal to O. Let these points be equal to AB and the point of the tangent be equal to C. As OC is a tangent to C2, it will be perpendicular to the chord AC. We know that the length of AB is equal to 6 centimeters. So therefore, the length of AC, which will be the midpoint, will be equal to 3 centimeters. We also assumed that the radius of the smaller circle C2 is equal to R. Therefore, the radius of the longer circle will be equal to R plus 1. Because as we have discussed earlier, if diameter is 2 centimeters longer, radius will be 1 centimeter longer. So if you just look at the triangle OAC, this is a right angle triangle. One of the non-hypotenuse sides is equal to R centimeters, the other non-hypotenuse side is equal to 3 centimeters, and the length of the hypotenuse is equal to R plus 1. In any right angle triangle using Pythagoras theorem, you have the square of the sum of the non-hypotenuse sides will be equal to the square of the hypotenuse side. Or in this particular case, R square plus 3 square will equal R plus 1 whole square. You can simplify this. This is equal to R square plus 9 is equal to R square plus 2R plus 1. You can cancel R square on both sides. Therefore, 2R will equal 8, or the value of R is equal to 4. Now, what are we asked to find out? We are asked to find out the diameter of C1. What is the radius of C1? That is, the radius of the longer circle will be R plus 1, which is equal to 5 centimeters. This is the radius of the longer circle. Therefore, the diameter will equal 5 into 2, that is 10 centimeters, which is the answer. In this question, it is given that there is an interior point in an equilateral triangle, and from that point, perpendiculars are drawn to all the three sides. The sum of the lengths of these three perpendiculars is given to be equal to S, and we are required to calculate the area of the equilateral triangle. So let us assume that this is the equilateral triangle. Let the three vertices be equal to A, B and C, and let the side of the equilateral triangle be equal to P. So AB is equal to P, AC is equal to P and BC is equal to P. Let the interior point be a point G, which lies somewhere inside. Let this be equal to G, and from G let us draw perpendiculars to all the three sides. So this will be one, this will be the other, and this is the third one. Let the lengths of the three perpendiculars be equal to A, B and C. So let this be equal to A, let this be equal to B and let this be equal to C. We are told that the sum of these perpendiculars is equal to S. So A plus B plus C is equal to S. Now we have to calculate the area of the triangle. So let us connect the point G to all the three vertices. So let us connect G to B. Let us also connect G to A, and let us also connect G to C. Now what is the area of the triangle? The area of the triangle ABC is the sum of the areas of AGC, that is this triangle, plus BGC, that is this triangle, and AGB, that is this triangle. That is the area of the triangle ABC. Now what is the area of AGC? It is equal to half into base into height. The base of AGC is the length AC, which is equal to P, and the height is equal to B. Similarly, BGC is equal to half into the base BC, which is also equal to P, into the height, which is equal to A. And the area of AGB is equal to half into AB, which is also equal to P, into the height, which is equal to C. Or the area of triangle ABC is equal to half into P into A plus B plus C. This is equal to S. This is equal to P into S divided by 2. But what is the area of an equilateral triangle? The area of an equilateral triangle is equal to root 3 by 4 into p square. So here we can cancel 1p and we can cancel 2 over here, and the value of s is equal to p into root 3 by 2, or the value of p is equal to 2s by root 3. So if you are trying to calculate the area of the equilateral triangle in terms of s, we have to calculate the value of root 3 by 4 into p square, which is equal to root 3 by 4 into 2s by square root of 3 into 2s by square root of 3. This is the area of the equilateral triangle. We can simplify this. We can cancel 4 in the denominator and root 3 in the numerator. This will equal s square by root 3. In this question, it is given that there are two circles. The radius of each of the circles is 4 centimeters. So let us first draw both the circles. They are touching each other. They touch each other externally. Each of the two circles is again touched externally by a third circle. If these three circles have a common tangent, so as there is a circle which is touching these two circles externally and there is a common tangent, let us assume that this is the common tangent and this is how the circles look like. Now we are told that the radius of the bigger circles is 4 centimeters. So this is 4 and this is 4. We are required to find out the radius of the smaller circle. Let us assume that the radius of the smaller circle is r. Now first thing you should do whenever you have circles which are touching each other is to join the centers. This won't work always, but this works most of the times, because you know immediately that the distance between the two centers is the sum of the radius of the circles. So first thing we'll do is connect all the circles, all the centers of the three circles. So you'll get a nice triangle. We know the sides of the triangle. The sides of the triangle are, for example, if you name the first center as A, the second center as B, for triangle ABC, you know that AB is equal to 4 plus 4, this is equal to 8 centimeters. Whenever there are two circles which are touching each other, the distance between the centers is the sum of the radii. Similarly, AC is equal to 4 plus r. Here we are assuming that the radius of the smaller circle is r and we need to find out the value of r. And the length of BC is also equal to 4 plus r. We know this. Now what we'll do is, we'll connect, if you just look at the triangle ABC here, ABC is an isosceles triangle because AC is equal to BC. This is A, this is B and this is C. We'll connect C, we'll draw a perpendicular from C to AB. Now the length of, say if this is touching at D, the length of CD is equal to 4 minus r. Why is this equal to 4 minus r? Because the length of D and say this point is E, the length of DE is also equal to 4, because DE is parallel to AF is parallel to BG. Because all these three lines are parallel, they are basically parts of rectangles. So we know that DE is equal to 4 and the value of CE, that is from the center of the smaller circle to the tangent, is r. So the length of CD, which is basically the height of the isosceles triangle, is equal to 4 minus r. So we know that this is equal to 4 minus r. We know that AC is equal to 4 plus r over here. We know that BC is equal to 4 plus r over here. And we know that AB is equal to 4. So basically BD is equal to 4 and AD is equal to 4. Now using this you can easily calculate the length of r. How can we do this? If you consider any one of the triangles, say ACD, this is a right angle triangle where 4 plus r is the hypotenuse and the two sides are 4 and 4 minus r. So in triangle ACD, which is a right angle triangle, AC square is equal to CD square plus AD square. AC square is 4 plus r square is equal to CD square is 4 minus r square plus AD square is 4 square. You can simplify this as 16 plus 8r plus r square is equal to 16 minus 8r plus r square plus 16. You can simplify this, you can cancel the common terms and you will get 16r is equal to 16 or r is equal to 1. To solve this question, the first thing we did was connect the centers of all the circles, then figure out that the centers of the circles form an isosceles triangle. Then we found out that the height of the isosceles triangle is 4 minus r. Once we found that, solving for r is very simple, and in this case r will equal 1. In this question we are given that there is a regular pyramid and the base of the regular pyramid is a square. So say this is a pyramid and this is the base of the pyramid. This is a square and each of the other 4 sides is an equilateral triangle. So this will be in another dimension where there is an equilateral triangle. All this, the other sides of the pyramid, which is basically in 3 dimension, will meet at an apex, and each of this is a equilateral triangle. The length of each side is 20 centimeters. So for the pyramid, the other 2 sides, the other 4 sides are 20 centimeters each, and they are all equilateral triangles. This would imply that even the base of the triangle, which we know is a square, the length of each side of the square is 20 centimeters. Now notice that the point where they made this is the apex of the pyramid, which is at the top. Now we are required to find out the vertical height of this pyramid. So what we will first do is, for each of the equilateral sides, which is along the side, we will find out the length of the median. So if you are looking only at the equilateral sides, which is one of the sides of the equilateral triangle of the pyramid, we know that it is an equilateral triangle of side 20 centimeters. So along one of those sides, if you draw a line from the apex to the bottom, which is bisecting the third side, that is, which is bisecting the base, the length of this side will be 10 root 3, because that is the median of the equilateral triangle of side 20. You can calculate that quite easily because this is 60 degrees, and so this will be 20 into sine 60, that is 20 into root 3 by 2, so that will be 10 root 3. Now consider just the base of the triangle, base of the pyramid. The base of the pyramid is a square. Now consider the point which is in the middle of the base. Now if you draw a line which is vertically to the top, it will come and meet the apex at some point. So say this is the apex. This is a vertical line of height, say h. Now again along the ground, you are drawing a line from the base, from the center of the base to the side of the pyramid. The length of this side will be 10 centimeters, because the length of the square is 20 centimeters. This will be exactly half of it. Now if you consider the apex as A and the center of the pyramid as C, and the point at which the line meets the side of the square as, say, D, ACD will be a right angle triangle. Now ACD will be a right angle triangle. The height of the right angle triangle is h, as we have just discussed. At the base it will be a right angle over here, and the length of the side along the ground will be 10 centimeters. This is CD. And when you draw a line in 3 dimension which meets from A to D over here, this will be along the side of the equilateral triangle that we have just discussed, and the length of it will be 10 root 3. Now using this we can actually calculate the value of h, which is the vertical height of the pyramid that we need. Because this is a right angle triangle, h square plus 10 square will equal 10 root 3 whole square, or h square will be 300 minus 100, which is equal to 200, or h is equal to square root of 200, which is equal to 10 root 2. Now what we have found out is one thing. We have first found out the length of, if you draw a line from the apex of the pyramid to the center of the square, that length will be 10 root 3 directly in 3 dimension. Then we have recognized that if you just consider the triangle where apex is one vertex, the center of the square is the second vertex, and the center of a side of the square is the third vertex, it will be a right angle triangle in 3 dimension. Now the sides will be h, 10 and 10 root 3. Using this you can calculate the value of h, which will equal 10 root 2. This is the answer. In this question we are given that ABC is a right angle triangle with hypotenuse BC of length 20 centimeters. So let us assume that this is the right angle triangle this is B, A and C. We know that BC is the hypotenuse and the length of BC is given to be 20 centimeters. Now we are told that AP is a perpendicular on BC from A. So This is a perpendicular. Now the maximum possible length of AP is equal to, we are required to find out the maximum value of AP. So let us assume that the length of AP is equal to R. We'll try to find out a function, the value of R as term as an expression, and then try to maximize the value of that expression. So let us start off by assuming that the length of AB is equal to X, the length of AC is equal to Y, the length of BP is equal to Z. Now if BP is equal to Z, the length of PC will be 20 minus Z. Why would it be 20 minus Z? Because we know that the length of BC is equal to 20. So we are just subtracting Z from 20. Now we will use Pythagoras theorem multiple times. That is in triangle ABP, x square, here x is the hypotenuse, is equal to R square plus Z square. Similarly in triangle APC, y is the hypotenuse, so y square is equal to R square plus 20 minus Z whole square. Now remember that ABC itself is a right angle triangle. So in triangle ABC, x square plus y square is equal to 20 square, where 20 is the length of the hypotenuse. So if you add the first equation and the second equation, we will get a term x square plus y square. Using substituting 20 square in place of it, we can eliminate both x and y. So that is what we are going to do next. So we will add 1 plus 2, that is these two equations. So x square plus y square is equal to r square plus r square, so that is equal to 2r square plus z square plus 20 minus z whole square. So that will be z square plus 20 minus z whole square. Now x square plus y square is equal to 20 square. So we'll substitute that. So 20 square is equal to 2r square plus z square plus 20 square minus 40z plus z square. This is just an expansion of 20 minus z whole square. Now we'll cancel out the common terms, that is 20 square, and we'll try to find out the value of r square. So 2r square is equal to 40z minus 2z square, or r square is equal to 20z minus z square. Now we'll have to vary z. The value of z can vary from 0 to 20 and try to maximize r square. You can do this in multiple ways. One of the ways that I do most often is by completing of squares. So 20 minus z whole square, I'll add and subtract 100 from both sides. This is equal to 100 minus 100 plus 20z minus z square. The reason I am adding and subtracting 100 is because I want to complete a perfect square. So here r square is equal to 100 minus z square minus 20z plus 100. This is equal to 100 minus z minus 10 whole square. This is the value of r square. So we know that r square is equal to 100 minus a perfect square. The value of a perfect square will be at least equal to 0. So the maximum value of r square will be 100, which will happen when z is equal to 10. So the maximum value of r is equal to square root of 100, which is equal to 10. This will happen when z is equal to 10, or ABC is an isosceles triangle and the perpendicular is actually a median which bisects the hypotenuse. Anyway, the answer that we are looking for is 10. The key to knowing this is knowing how to complete a square and using Pythagoras theorem multiple times. The answer is 10 centimeters. A man has three metals, iron, aluminium and copper. So the volume of iron is 405 centimeter cube, volume of aluminium is 783 and volume of copper with him is 351. Using these metals he is making small cylinders. The radius of each of the small cylinders is 3 centimeters. We don't know the height. So we have to ensure that the volume of each of the small cylinders have the same volume. So let us assume that the volume of the small cylinders is V. So as the total metal is 405, for example in iron, the number of small cylinders that he'll make which are of iron is 405 by V. Similarly, the number of aluminium that he'll make is 783 by V, and the number of copper that he'll make is 351 by V. These are the different cylinders of different metals that he'll make. Now we have to ensure that the total number of such cylinders is kept at a minimum. That is, we want the sum of these three numbers, that is the number of cylinders of each metal, to be at the minimum. And then we are required to find out the total surface area of each of these cylinders. So what we'll do first is we'll figure out at what value of V will the total number of cylinders be minimum. Use that value of V. From that value of V, we'll get the volume of the cylinders. We already know the radius. So for each of the small cylinder, we'll calculate the height. Then we'll calculate the total surface area of all the cylinders. But first thing, if you want to minimize the sum of 405 by V plus 783 by V plus 351 by V, we have to keep V as high as possible. But we should also ensure that each of these three numbers are natural numbers, because they represent the number of cylinders of each metal. So they can't be fractions. So V has to divide 405, V has to divide 783, and V has to divide 351. That is, V should be a factor of all of these three numbers, and V should be as high as possible. This implies that V should be the HCF, that is the highest common factor of 405, 783 and 351. So now if you are given three numbers and if you have to find the highest common factor of these three numbers, there is one small trick which you can use. That is, the HCF of three numbers A, B and C will be the HCF of A minus B, B and C. You can choose any two numbers A and B. If you subtract their, if you find their difference, the HCF should even be a factor of the difference. So in this case, to quickly find out the HCF of these three numbers, we will subtract 351 from 405, because these are the two numbers which are closest to each other. We can find one number to be small, and from then we can find out the HCF easily. So in this case, the HCF will equal 405 minus 351 is 54, 783 and 351. Now if you look at 54, you can figure out that it is a multiple of 9. So we will calculate, it's a multiple of 9 and it's a multiple of 27 and 2. Clearly the other two numbers are odd numbers, 783 and 351. So we will check if 27 divides either of these two numbers. 783, for example, is 810 minus 27. 810 is 27 into 30. So 783 can be represented as 27 into 29. Similarly, 351, if you calculate, can be represented as 27 into 13. So clearly 27 is a multiple of the other two numbers, and we know that 54 is equal to 27 into 2. So the HCF of these three numbers is equal to 27. So the volume V is 27. So the volume of each of the small cylinders is equal to 27. And the number of such cylinders will be 405 by V. 405 by 27 is equal to 405 is equal to 27 into 15. So you will have 15 iron small cylinders. Of aluminum you will have 29 because 783 by 27 is equal to 29, and for copper you will have 351 by V, which is equal to 351 by is equal to 13. So the total number of small cylinders that you will have is 15 plus 29 plus 13. This will equal 57. Now let us calculate the height of the small cylinders. We need the height to calculate the total surface area. So if the height is h, the volume of the small cylinder will be pi into r square into h. This is equal to 27. We know that r is equal to 3. So pi into 9 into h is equal to 27, or h is equal to 3 by pi. So each of the small cylinder, the height is 3 by pi, the radius is 3 centimeters, and the total number of such small cylinders is 57. We just need to calculate the total surface area. Now for any given cylinder, the total surface area is equal to 2 pi r into r plus h. In this case, for each of the small cylinder, the total surface area will be equal to 2 pi into r is 3 into 3 plus 3 by pi. Now you can cancel pi, so this will become 6 pi. You can take 3 also outside, so it will be 18 into 1 plus pi. This is the total surface area of each of the small cylinders. but we have 57 such small cylinders. Therefore, for the entire all these cylinders, the total surface area will be 57 into 18 into 1 plus pi. If you calculate it, you will find out that this is equal to 1026 into 1 plus pi. That is the answer. So there are two steps in this. First, you have to calculate what is the volume of each of the small cylinder. The volume has to be a factor of each of the three numbers that are given, that is 405, 783 and 351. And it should also be as high as possible because we want to keep the number of cylinders to be at its minimum. Once you figure out that the volume has to be the highest common factor of these three numbers, we then calculate what is the highest common factor. We figure out that it is 27. Using the fact that the volume is 27, we calculate the height of the small cylinder, that is equal to 3 by pi. Then we calculate the total surface area of each of the small cylinders, and then we calculate the total surface area of all the 57 small cylinders.
Google search Krakow CAT formulas PDF. Click on the first link. You will get a list of topics for CAT. Click on one of the topics. Download the PDF to get a list of formulas for the topic.
In this question, it is given that there is a triangle ABC. The medians AD and BE are perpendicular to each other. So suppose we have ABC, this is a triangle. Now we draw the two medians, this is BE and there is AD. Now we are told that they are perpendicular to each other. It might not appear here, but it is given in the question. Now the length of AD is given as 12 centimeters and the length of BE is given as 9 centimeters. We are required to find out the area of triangle ABC. Now what we will do over here is, we will first find out, suppose the median is G, we will first find out the lengths of AG, DG, BG and GE. Because we know the lengths of AD and BE, we can infer that the length of AG is equal to 2 by 3 into 12, which is equal to 8 centimeters. Why is this the case? Because in any triangle, the centroid always divides the medians in the ratio 2:1. So if you have any triangle and you are given one median, say from A to D, and you are given the median G, then the median divides the centroid divides the median in the ratio 2:1. In this case, we are told that AD is equal to 12 centimeters. Therefore, the length of AG will be 2 by 3 into 12, which is equal to 8 centimeters. And the length of GD will be equal to 1 by 3 into 12, which is equal to 4 centimeters. So, similarly, we can calculate the lengths of BG. In this case, the length of the median is 9 centimeters. So, the length of BG will be 2 by 3 into 9, which is equal to 6 centimeters. And GE is equal to 1 by 3 into 9, which is equal to 3 centimeters. So if you input this in the diagram, BG is 6 centimeters, GE is 3 centimeters, AG is 8 centimeters and GD is 4 centimeters. Now what we will try to do is find out the area of triangle ABD. This is basically the triangle formed between A, B and the point the median touches the line BC. Once we find it out, we can easily say that the area of triangle ABC will be twice the area of triangle ABD. Because again, in any triangle, if you calculate the length of one half where the median divides it, the total area of the triangle will be twice of that. So in order to calculate the area of ABD, we can find out that ABD is actually equal to the sum of two right angle triangles. One right angle triangle is BGD and the second right angle triangle is ABG. Both of them are formed when AD and BE intersect each other at a right angle. Now the area of triangle BGD can be easily found out because we know that one of the side is 6 and the other side is 8. So the area is half into 6 into 8. Similarly, ABG is another right angle triangle and its sides are 6 and 4. Therefore, its area is half into 6 into 4. Therefore, the area of the triangle ABD, which is one half of ABC, will equal half into 6 into 8 is half into 6 into 8 is 48 by 2, which is equal to 24, and half into 6 into 4 is 24 by 2, which is equal to 12. So this is equal to 36 centimeters. Now this is the area of ABD, which is 1/2 of the triangle ABC. Therefore the area of triangle ABC is equal to 2 into 36, which is equal to 72 centimeters. In this question we have learned two things. One thing that we have learned is that the centroid always divides the median in the ratio 2:1. The second thing we learned is that once you find out the length of a triangle where the median intersects the third side, the length of the area of the total triangle will be twice of the smaller triangle. That is, for example, if there is ABC and there is the median is AD, which intersects the third line BC at D, if you are able to find out the area of ABD, the length of ABC, which is the whole triangle, will be twice the length of A, B and D. So in this case the answer is 72 centimeters, 72 centimeters square. In this question it is given that A and B are two regular polygons and they have A and B sides respectively. So there is a polygon A and there is a polygon B. The number of sides of A is A and the number of sides of B is B. It is given that B is equal to 2A and each interior angle of B is 3 by 2 times each interior angle of A. So the interior angle of A, let us assume it is equal to x, then each of the interior angles of B is equal to 3x by 2. We are required to find out the interior angles of a polygon which has A plus B sides. Now this is the question. To find out, let us first do a small diversion. We will talk about what is interior angle and what is exterior angle. So suppose you have a regular hexagon. All the angles which are inside are interior angles and all the angles which are outside are exterior angles. So for example, if this is a regular hexagon, this angle is an interior angle and the angle which is basically supplementary to it will be a exterior angle. So if say this is A, the exterior angle will equal 180 minus A. This is true for all of the vertices. So if say this is B, then this will be 180 minus B. So the exterior angle will be 180 minus B whenever the interior angle is equal to B. Now there are many formulas that you can remember with respect to interior angles and exterior angles, but the one formula that I use to avoid confusion is that the sum of all the exterior angles of any convex polygon is equal to 360 degrees. So if you have many exterior angles, the sum of all the exterior angles of any convex polygon is equal to 360 degrees. So in this case what I will do is I will first find out the exterior angles. So the exterior angles of A will equal 180 minus x. Because all the angles equal x, all the interior angles equal x, all the exterior angles will equal 180 minus x. And all the exterior angles of B will equal 180 minus 3x by 2. Now sum of all the exterior angles of A will equal 360 degrees and sum of all the exterior angles of B will also equal 360 degrees. If we just put those into formulae, there are 180 minus x into A. The number of exterior angles in A is small a, this is the number of sides that A has, and each of the exterior angles equals 180 minus x. This is equal to 360 degrees, which is also equal to 180 minus 3x by 2, which is the exterior angles of polygon B into the number of sides of B, which is equal to B. This is the sum of all the exterior angles of B and this is the sum of all the exterior angles of A. Both the sums will equal 360 degrees. Using this, we will calculate the value of x. From x, we will calculate the value of small a and small b, then calculate the required answer. So we can use it, we can use the formula that we can use the equation that b is equal to 2a to simplify this. So 180 minus x into a is equal to 180 minus 3x by 2 into 2a. We can cancel a, so 180 minus x is equal to 360 minus 3x, or x is equal to 90 degrees. So each of the interior angles of A is 90 degrees and each of the interior angles of B is equal to 135 degrees. So as each of the interior angles of A is equal to 90 degrees, the number of sides of A is 4. It is a square. And the number of sides of B will be B is equal to 2A, so that is equal to 8. So what we are required to find out is interior angles of a regular polygon which has A plus B, which is equal to 12 sides. Now again, to do this, what we will do is calculate the exterior angle. Each of the exterior angles of a polygon which has 12 sides will equal 360 by 12, which is equal to 30 degrees. Therefore, each of the interior angles will equal 180 minus 30, which is equal to 150 degrees. So if you have noticed this, in all the equations, what we have done is we have first found out the exterior angles. We have used the formula that the sum of exterior angles of all the polygons, whether it has 4 sides or 8 sides or 12 sides, the sum of the exterior angles of a convex polygon will always equal 360 degrees. We have used that to find out the value of A, then we have found out the value of B, and we have found out the value of A plus B, which is equal to 12. Once we have found out that A plus B is equal to 12, we found out that each of the exterior angles of a 12-sided polygon will equal 30 degrees, and hence each of the interior angles will equal 180 minus 30, which is equal to 150 degrees. Now there are many ways in which you can calculate this. There will obviously be formulas of the dimensions of the interior angles directly, but what I feel is just keeping track of the exterior angles is less confusing. We would not use one formula from the other, and even though it takes slightly more time, we will be able to get the answer for sure with a lot of accuracy. So anyway, in this question the answer is 150 degrees. In this question we are given that AB is the diameter of a circle of radius 5 centimeters. Let us first draw AB. So this is, suppose this is a circle, and we have, this is A and this is B, and AB is the diameter. The radius of the circle is given as 5 centimeters, so the length of AB, because AB is the diameter, is 10 centimeters. P and Q are 2 points on the circle such that the length of PB is 6 centimeters. So suppose this is P, the length of PB is given as 6 centimeters. The length of AB is 10. And the length of AP is twice the length of AQ. So the length of AP we'll first find out, and before we get into the calculation of AP, we should know one simple thing, that is, if there is a diameter of a circle and you connect both of them to any point on the circle, it need not be any specific point, it will always be a right angle. So assuming that this is say this is K and L, this is the diameter. If you connect K and L to any point on the circle, they will form a right angle triangle. So for example, even this will be a right angle triangle. Any point on the circle when connected to the opposite ends of a diameter will always be a right angle. This is a theorem which you can remember. So in this case, APB will be a right angle triangle, and the hypotenuse is 10 centimeters and one of the side is 6 centimeters. Therefore, the length of AP will equal, by Pythagoras theorem, square root of 10 square minus 6 square. Again, a very simple thing which most of you would already know is that in a right angle triangle, if one of the side is A and the other side is B, the side opposite the right angle triangle, which is the hypotenuse, the formula is A square plus B square is equal to C square. This is the Pythagoras theorem, which is quite useful. So using this formula, we can calculate the length of AP. This will be square root of 10 square minus 6 square. This will be square root of 100 minus 36, which is equal to square root of 64, which is equal to 8 centimeters. So we know that the length of AP is 8 and the length of AP is twice the length of AQ. Therefore, the length of AQ will be 8 by 2, which is equal to 4 centimeters. So suppose Q is a point somewhere over here such that this is AQ, this is 4 centimeters. Then the length in centimeters of QB is nearest to. So we need to find out the length of QB. Again, using the earlier theorem about a diameter and subtending right angle triangle at on any point on the circumference, here AQB is also a right angle triangle and the hypotenuse is the same, which is 10 centimeters. Here one of the side is 4 centimeters, therefore the length of the other side will be square root of 10 square minus 4 square, which is equal to square root of 100 minus 16, which is equal to square root of 84. This is the length of BQ. And square root of 84, you can use a calculator to find out that this is something like 9.16 centimeters. Amongst the options that are given, the only option which is closest to it is 9.1. So the answer in this case is 9.1 centimeters. In this question, it is given that there is a circle of radius 11 centimeters, of which CD is a diameter. So suppose there is a circle, CD is the diameter, the length of the radius is 11 centimeters, so CD, which is the diameter, is equal to 22 centimeters. There is a chord AB of length 20.5 centimeters. AB and CD intersect at point E inside the circle. So let us assume that this is AB. And AB, the length of AB, it is given, is equal to 20.5 centimeters. CE has a length of 7 centimeters, so this is 7. Then the difference of the lengths of BE, this is E, and AE in centimeters. So we are required to find out BE minus AE. This is the difference. So before we get into it, there is one theorem, important theorem in geometry. It is quite straightforward, which is called the intersecting chords theorem. We'll use that theorem in this problem. We can solve it without using it also, but using it, the solution becomes very straightforward. So suppose there is a circle and suppose it has two chords. Now suppose the chords are AB and CD, and suppose they intersect at S. This can be any two chords in the circle. Then AS into BS is equal to CS into DS. What we are saying is, when we multiply the respective lengths of each of the small parts from the point of intersection, the product will remain the same. So AS, which is this point, this length, into BS, which is this length, will equal CS, which is this length, into DS, which is this length. You can prove it using similarity of two triangles, because many of the angles are equal when you complete the triangles. But there is no need of proof, just remember this theorem, it is an important theorem. We'll apply the same theorem in this problem, because as you can see, AB is a chord and CD, even though it's the diameter, is also another special chord. So once we know that CE is equal to 7 centimeters, we know that DE is equal to 15 centimeters. We know the length of DE because we know the length of CD, it is equal to 22 centimeters, so DE is equal to 15. Let us assume that the length of AE is equal to X, so the length of BA will be equal to 20.5 minus X, because we know the length of AB. Now using the theorem that we just described, the intersecting chords theorem, it would mean that 20.5 minus X into X is equal to 7 into 15. This is a quadratic equation in X. You can simplify it by expanding the bracket. So it will be X square minus 20.5X plus 105 is equal to 0. 20.5 is 10 plus 10.5. You can factorize this easily as X minus 10 into X minus 10.5 is equal to 0. So it has two solutions. Solution 1 is that X is equal to 10 and solution 2 is equal to X is equal to 10.5. Therefore, the length of AE is either 10 centimeters or 10.5 centimeters. In this case, the length of BE is equal to 20.5 minus X, which is equal to 10.5. And in this case, the length of BE is again equal to 20.5 minus X, so BE is equal to 10. In both the cases, the difference between the two chords, the two line segments B and AE, will be 10.5 minus 10, which is equal to 0.5 centimeters. So the answer in this case is 0.5 centimeters. This is a good use of the theorem that we discovered, intersecting chords theorem. Just read it so that you will understand this better. In this question, it is given that the corners are cut off from an equilateral triangle T to produce a regular hexagon H. Then the ratio of the area of H to the area of T is, this is what we are required to find out. So suppose there is an equilateral triangle. Suppose this is the equilateral triangle.
Now the corners are cut off from the triangle to form a regular hexagon. So suppose this is the hexagon that is formed. Now we are required to find out the ratio of the area of the hexagon to the area of the equilateral triangle, the original equilateral triangle. Let us assume that each of the side of the hexagon is A. Now by symmetry, the part that is cut off from the triangle will also be A. That is, this will be A, 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 and this will be A. Why will it be A? Because you can actually prove that the smaller equilateral triangles that are shown are also equilateral triangles. That is, the smaller triangles, these three smaller triangles themselves are equilateral triangles. It is quite easy to prove that because the angle of the hexagon will be 120 degrees. So all the angles of each of the smaller triangles will be 60 degrees. And the original angle is also 60. So it is quite easy to prove that each of the smaller triangles that are formed are equilateral triangles. So all the sides will be A. So in this old triangle, old equilateral triangle, the length of the side, length of each side is equal to 3A. This is A plus A plus A, 3A. Therefore the area of the equilateral triangle, area of T, is equal to, we know the formula for the area of an equilateral triangle, which is root 3 by 4 into S square, where S is the length of each side. In this case it will be root 3 by 4 into 3A square, which will be root 3 by 4 into 9A square. Now we can use the formula to find out the area of the hexagon of side A, but if you are not able to remember it, we will just calculate the total area of the three smaller equilateral triangles and subtract it from 9A square to find out the area of the regular hexagon. So area of smaller equilateral triangle is equal to root 3 by 4 into A square. Now we have three such equilateral triangles at each of the corners. So the total area that has to be subtracted will be root 3 by 4 into 3A square. Now if we subtract this from the original area, we are going to get the area of the hexagon. So area of hexagon is the first area minus the second area, which will be, we can take root 3 by 4 common, 9A square minus 3A square, which will be 6A square. Now the required ratio that we have to find out is 6A square by 9A square, because we can cancel root 3 by 4. So that will be 6 by 9, the ratio of the area of the hexagon to the area of the original equilateral triangle, which will be 2 by 3. So in this case the answer is 2 by 3. Once we figure out that each of the smaller triangles formed are equilateral triangles and then get a ratio of the side of the hexagon to the side of the original equilateral triangle, we can get the answer quite fast. In this question it is given that there is a brick and the rectangular faces of the brick have diagonals. So the diagonals are in the ratio 3:2 into root 3 to the ratio root 15. We are required to find out the ratio of the length of the shortest edge of the brick to that of the longest edge. So suppose that there is a brick like this. This is a cuboid as given in the question. Now the cuboid will have three diagonals on the face. So if the length of the sides are A, B and C, the length of one of the diagonals of each of the faces will be square root of A square plus B square. The second diagonal will be square root of B square plus C square, and the third diagonal will be square root of C square plus A square. These are the three sides. Now we are given the ratio of each one of them. So let us assume that this is equal to 3, this is equal to 2 root 3 and this is equal to root 15. Using these three equations, we can find out the value of A, B and C. We can find out which of the following is the longest and which of the following is the shortest, and then find the required ratio. Because this is the ratio, let us assume that this is 3k, 2 root 3k and root 15k, where k is a constant. Now we can square each one of them to get three different equations, which is A square plus B square is equal to 3k whole square, which is 9k square. Using the second equation, B square plus C square is equal to 2 root 3 into k whole square, which is equal to 12k square. And the third one is C square plus A square is equal to 15k square. The easiest way to calculate the value of each one of them a, b, c is sum all the three equations because of symmetry, and if you simply calculate, you are going to get 2 into a square plus b square plus c square is equal to the sum of these three. 9 plus 12 is 21, 21 plus 15 is 36k square. Therefore, the sum of the three squares, that is a square plus b square plus c square, will be 18k square. Now you can subtract each of the equations individually to find out the value of a, b and c. For example, from the first equation, we will get that the value of c square is equal to 9k square, because the sum of a, b and c is 18 and a plus b is 9, so c square is 9k square. Similarly, from the second equation, you will get that a square is equal to 18k square minus 12k square, which is 6k square. Similarly, from the third equation, you will get that b square is equal to 3k square. Clearly, b is the smallest and c is the longest. So, c is equal to square root of 9k square, which is 3k, which is the longest side. And the shortest side is b, which is equal to root 3 into k. You will get this from the third equation. This is the shortest. Now, what you are required to find out is the ratio of the length of the shortest edge to the of the longest edge. So, the required ratio is root 3k is to 3k, which is equal to 1 is to root 3. This is the answer. In this question, let us see, let T be the triangle formed by the straight line 3x plus 5y minus 45 is equal to 0 and the coordinate axis. So let us draw the triangle so that we can understand what exactly this means. So the triangle will be something like this. This has a negative slope, 3x plus 5y is equal to 45 and the coordinate axis. So let us assume that this is origin, this is A and this is B. To calculate the coordinates of point B, because B is on the x-axis, the value of y is 0. So when you substitute y is equal to 0 in this, 3x is equal to 45 or x is equal to 15. So the value of b will be 15, 0. Similarly, a is on the y-axis, so the value of x will be 0. So if you substitute x is equal to 0 in the equation, you get 5y is equal to 45 or y is equal to 9. So we have the coordinates of A, we have the coordinates of B, and we have the coordinates of origin. Now let the circumcircle of T have a radius of length L, measured in the same unit as the coordinate axis. We need to find out the integer closest to L. So one of the things that you should remember is that in a right angle triangle, the circumcircle, the hypotenuse will be the diameter of the circumcircle. So the circumradius of a right angle triangle will be hypotenuse by 2. So this is something that you can remember. In any right angle triangle, if you want to find out its circumradius, first find out the length of its hypotenuse. The hypotenuse will be the diameter of the circumcircle, and so divide the hypotenuse by 2 to get the circumradius. Now in this case, to find out the length of the hypotenuse is just AB. So the length of AB will be square root of 9 square plus 15 square. This is because the length of AO is 9 units and the length of BO is 15 units. Using Pythagoras theorem, the length of AB will be square root of 9 square plus 15 square, which will be square root of 81 plus 225, which is equal to square root of 306. If you use your calculator, it will be something close to 17.5 units. This is the hypotenuse. So to find out the radius, the circumradius, we have to divide this by 2. So the circumradius L will be 17.50 by 2, which is equal to 8.75 units. Now we are required to find out the integer closest to L. The integer closest to L will be 9. So the answer in this case is 9. In this question, it is given that there is a circle and two parallel chords on the same side of the diameter have lengths 4 centimeters and 6 centimeters. So let us draw the circle first. Say this is the circle, this is the center, then there are two parallel chords, and the length of both the chords, let us name so that it is easier to remember, A, B, C, D, and let the center of the circle be O. Now we are told that AB is parallel to CD. We are also told that the length of AB is 4 centimeters and the length of CD is equal to 6 centimeters. If the distance between these two chords is 1 centimeter, so we are told that the distance between these two is 1 centimeter. We are required to find out the radius of the circle in centimeters. So whenever you are given a chord and the center of the circle, one of the first things that you should do in most of the cases is connect the center of the chord with that of the center of the circle. This will be a right angle. So the theorem is that if there is a circle and if there is any chord in the circle, if you connect the center of the circle to the midpoint of the chord, it will be a right angle triangle, right angle. So we'll do the same thing over here also, because then it makes things very easy. Now we know that OD is equal to the diameter. We also know that OB is equal to the diameter. Let the diameter be equal to R. Now let both the points, both the midpoints of both the chords be equal to, say, P and Q. We are given that this 1 centimeter is equal to the length of PQ. Now if you look at it, there are two right angle triangles. One is OBP, which is the radius, the midpoint of one of the chords, and joining the center to it. So that will be one right angle triangle. And the second right angle triangle is OQD. This is the second right angle triangle. Now we will use Pythagoras theorem to find out the value of R. Let us assume that the length of OQ is equal to P. Therefore, in right angle triangle OBP, that is OBP, R square, R is the hypotenuse, the radius is the hypotenuse, is equal to OP square plus PB square. Now OP is equal to OQ plus 1, because we already know that the length of PQ is equal to 1 whole square plus PB square. Now we know that PB is equal to half of AB. So the length of PB is equal to two centimeters. The length of PB over here is 2 centimeters, and the length of OP, that is this, is equal to P plus 1. Therefore, R square is equal to P plus 1 whole square plus PB square, that is 4. Similarly, in triangle OQD, in the smaller right angle triangle, so to say, R square is equal to OQ square plus QD square. Now again QD is equal to CD by 2, so this equals 3 centimeters. We are saying this is equal to 3, and the length of this we assumed is equal to P. So R square is equal to P square plus QD square, that is 3 square, that is equal to 9. So in these two equations, because R square is common, P plus 1 whole square plus 4 is equal to P square plus 9. We can simplify this, we can cancel P square on both sides, so this will become P square plus 2P plus 1 plus 4 is equal to P square plus 9. We can cancel P square, and 1 plus 4 is 5. So if you subtract 5 from 9, this will become 4. So P is equal to 2 centimeters. Therefore, R square is equal to P square plus 9, P is 2, so this will be 4 plus 9, this is equal to 13. So the value of R is equal to square root of 13. Now the only thing that we need to know to really solve this, other than Pythagoras theorem, is that if you connect the center of the chord, the midpoint of the chord, to the center of the circle, it will be a right angle. So once you know this and you connect the center of the chords, both the chords, you just need to apply Pythagoras theorem twice to find out the length of the radius as well as the length of P, which is the length of OQ. Once you find that, you are going to find that the radius of the circle is square root of 13 centimeters. In this question, it is given that ABC is a rectangle which is inscribed in a circle of radius 13 centimeters. So let us first draw the circle. Once you draw the circle, you draw the rectangle in the circle. Now this is the rectangle. So let this be A, B, C and D. Which of the following pairs can represent in centimeters the possible length and breadth of ABCD? So let AB be the length, which is equal to L, and let AD be the breadth, which is equal to B. So we are required to find out which of the following pairs can represent L, B. Now the first thing that you should draw is draw the diameter. The diagonal of a rectangle which is inscribed inside a circle will be the diameter. Why will this be the diameter? Because if you draw a circle and when you have a diameter, if you connect any 2 points to the center, this angle will be 90 degrees because the diameter subtends 90 degrees at the circumference. So when you connect the diagonal, it will be the diameter of the circle. Now you know that the length of the diameter is 26 centimeters. So diameter is equal to 2 into radius, which is equal to 26 centimeters. Therefore the length of BD is equal to 26 centimeters. Now you already know that because this is a right angle and this is 90 degrees. We'll use Pythagoras theorem in this case also. So L square plus B square is equal to BD square because ABD is a right angle triangle. Therefore, L square plus B square is equal to D square, or L square plus B square. We know that BD is equal to 26. So 26 square is 676. Now we have to find out which of the 4 pairs the sum of the squares will equal 676. Let us start with D. 24 square plus 12 square is equal to 24 square is 576 plus 12 square is 144. So the sum of the squares will be 0, 1, 7 plus 1 is 11 plus 1 is 2. So it will be 720. So this is not the answer because we need the sum of the squares to equal 676. If you look at C, 25 square plus 10 square will equal 25 square is 625 plus 10 square is 100. So this equals 725. So option C is also not the answer. Now let us look at option B. It is 25 square plus 9 square. 25 square is 625 plus 9 square is 81. So sum of the squares will be 607, 706. So even this is not the answer. Now let us look at the final option, which is option A. 24 square plus 10 square is equal to 576 plus 100. This is equal to 676. This is actually what we want. We want the sum of the squares of the length and the breadth to equal 676. So the answer in this case is option A. In this question, it is given that there is a square ABCD and points E, F, G, H lie on the sides of the square. So let us draw the square. So let us assume that this is the square A, B, C and D. Now points E, F, G, H lie on the sides of the square such that E, F, G, H is also a square. So it would mean that suppose this is E, then this is F, suppose this is G and this is H. Now we are told that if we connect all these points, the 4 points inside the square E, F, G, H, this itself is a square. This would mean that EB, let us assume that this is X and let us assume that A is equal to 1. Now E, F, G, H will be a square only if all the 4 points E, F, G, H intersect A, B, C, D in proportional ratio. So for example, this would mean that CF is also equal to X and BF is equal to 1. Similarly, GC is equal to 1 and GD is equal to X. Similarly, DH is equal to 1 and AH is equal to X. What we are saying is EFGH will be a square only if EB is equal to FC is equal to GD is equal to AH. This is by symmetry. This would also imply that AE is equal to BF is equal to GC is equal to DH. Now then what we are assuming is that let the length of the side AB be equal to 1 plus x, and we are assuming that the first part, that is these 4 points, the length of these 4 small line segments is equal to x. Therefore the length of the remaining line segment AE is equal to 1. Once we have this, we have some more information. We are told that CG is longer than EB. CG, the length of CG is 1 because CG is greater than EB. The length of CG is 1 and the length of EB is x. So we are also told that x is less than 1. What we are again told is that the length of the square EFGH is 62.5% of the length of the area of the square ABCD. Now area of ABCD is equal to length square. Now each of the side of the square ABCD is 1 plus x. Therefore the area of ABCD is 1 plus x whole square. Similarly for EFGH, let us calculate the length of one side. The length of EF, for example this, by Pythagoras theorem is equal to square root of x square plus 1. Therefore the area of the square EFGH is equal to length square again, which is x square plus 1. Now what we are told is that x square plus 1 by x plus 1 whole square is equal to 0.625 or 62.5%. Using this equation, we will find out the length of x. Once we find out the length of x, we are required to find out the ratio of EB to that of CG. Now EB is x and CG is 1. So we are required to find out the value of x by 1, which is basically the value of x. So we'll just solve this equation, then we are going to get the value of x. It's a quadratic equation. So x square plus 1 is equal to 0.625 into x plus 1 whole square. Now x plus 1 whole square is x square plus 2x plus 1. When you multiply the terms inside the bracket with 0.625, it will be x square plus 1 is equal to 0.625 x square plus 1.25x plus 0.625. You can simplify this by taking all the terms to the other side. So it will be 0.375 x square, this is 1 minus 0.625, minus 1.25 x plus 0.375 is equal to 0. Now you can use your calculator, or you can observe that each of these coefficients is a multiple of 0.125. So for example 0.375 is equal to 0.125 into 3 and 1.25 is equal to 0.125 into 10. So what we'll do is we'll divide each of the coefficients by 0.125, or basically we'll multiply each of the coefficients with 8. That is equal to 1 by 0.125. So we will multiply each of the coefficients with 8. So 0.375 into 8 is equal to 3. So 3x square minus 1.25 into 8 is 10x plus 0.375 into 8 again is equal to 3. This is equal to 0. This is a simple quadratic equation. This will be 3x square minus 9x minus x plus 3 is equal to 0, or 3x minus 1 into x minus 3 is equal to 0. So x is either equal to 1 by 3 or x is equal to 3. But what we know is that x is less than 1. So x cannot equal 3. So x has to equal 1 by 3. Now once we know that x is equal to 1 by 3, we are required to just find out the value of x, which is 1 by 3. So the answer in this case will be 1 by 3 or 1:3. This is the ratio. So in this case we have just drawn the diagram. We have understood that if EFGH is a square, it would mean that all these 4 line segments EF, FC, DG and AH have to be equal. So we assumed that the length of each of those 4 line segments is equal to x. We have also assumed that the length of the remaining line segments is equal to 1, just to simplify our calculations. So AE will equal 1, similarly BF will equal 1, similarly GC will equal 1 and HD will equal 1. So once we have both of this, we know that the length of the bigger square, length of the side of the bigger square will be 1 plus x. Then we have calculated the ratio of the areas of the smaller square to that of the bigger square in terms of x. We got a quadratic equation in x. We solved it to find out that the value of x is 1 by 3 and we are required to find out just the value of x. So the answer in this case is 1:3. In this question it is given that there is an equilateral triangle T1 with side equal to 24 centimeters. So suppose this is the equilateral triangle T1. The length of the side L is equal to 24 centimeters. A second triangle T2 is found by joining the midpoints of the sides of T1. So the midpoints of the sides are these, and once you join them you are going to get a smaller equilateral triangle. This is called T2. Similarly, a third triangle is formed joining the midpoints of the side of T2 and the process continues. We are required to find out the sum of the areas of T1 plus T2 plus T3 plus dot dot dot. What we will try to find out is, we will try to see if there is some sort of a pattern that is possible wherein we can get a relationship between T2 and T1, that is the area of T2 and the area of T1 and the area of T3 and the area of T2 and so on. Then we can find out the sum of the areas of T1, T2, T3 and so on quite easily. Now if you look at it, this is a smaller equilateral triangle and the length of each side of this equilateral triangle, if the side of the bigger equilateral triangle is A, this is A by 2 and this is A by 2. Similarly, this will also be A by 2 and this will also be A by 2 because these are the midpoints. This is also equal to A by 2 and this is also equal to A by 2. So, and this is 60 degrees. So the smaller triangle T2 is also an equilateral triangle and the length of the side of the smaller triangle is exactly half the length of the larger triangle. So the area of T2 will be exactly 1/4 the area of T1. This is because each side of T2 is half the side of T1. The area of T2 will be 1/4 that of T1. Similarly, T3 will be equal to 1/4 of T2 and T4 will be 1/4 of T3 using the same logic. That is, as we keep going further and further, every consecutive triangle will have 1/4 the area of its predecessor. You can even look at it pictorially. So if you look at it, there are 4 equilateral triangles within T1 and each of them is exactly equal to the other. So this is the first equilateral triangle, this is the second equilateral triangle, this is the third equilateral triangle and T2 is the fourth equilateral triangle. So the area of T2 is 1/4 that of T1. You can find that in multiple ways. Now when we are required to find out the value of T1 plus T2 plus T3 plus so on, this is actually equal to T1 plus T2 is equal to 1/4 of T1 plus T3 is equal to 1/4 of T2. But because T2 itself is equal to 1/4 of T1, this will be 1/16 of T1 and so on. So this is a geometric progression where the common ratio is 1/4. So this is an infinite geometric progression where the common ratio is 1/4. Now whenever you have a geometric progression where it is AR square and AR cube and so on, where the terms are where the first term is A and the common ratio between two consecutive terms is R, the sum of such a geometric progression where the number of terms is infinite is A by 1 minus R. Note that R has to lie between -1 and +1. That is, the consecutive terms have to continue to become lesser and lesser. At least the absolute value of the consecutive terms has to continue to decrease. In that case, the sum of the geometric progression is A by 1 minus R. In this case, the first term of the geometric progression is T1. The area of T1 we can easily calculate because we know the side, the length of the side, and the common ratio R is equal to 1/4. Therefore, the total area of T1 plus T2 plus T3 and so on will equal T1 by 1 minus 1/4. This is equal to 4/3 into T1, where T1 is the area of the bigger equilateral triangle. Now the area of the bigger equilateral triangle is √3/4 into A square, which is 24 into 24. Remember that if there is an equilateral triangle of side A, the area of the equilateral triangle is √3/4 into A square. In this case, we know that A is equal to 24. So this is the area of the biggest equilateral triangle, that is T1. Now we are required to find out 4/3 into this area. So the required answer is a simplification of this calculation. root 3 by 4 into 24 into 24 into 4 by 3. If you simplify this, 24 into 24 is 576. 576 by 3 is 192. So the required answer is 192 into square root of 3 square centimeters. So the answer is 192 root 3. The first thing that you should observe is each triangle, the area of each subsequent triangle is 1/4 the area of its predecessors. Once you understand that, finding the value of T1 plus 1 by 4 T1 plus 1 by 16 T1 and so on is very easy. In this question, it is given that there is a right circular cone. The height of the circular cone is 12 feet and it stands on its base with a diameter of 8 feet. So this is how the cone is. It looks like a triangle from one side. So the height has been given as 12 feet. Now the radius is given as 4 feet. We are told that the diameter is 8 feet, so the radius is 4 feet. The tip of the cone is cut off with a plane which is parallel to the base and 9 feet from the base. So at a height of around 9 feet, so this is given as 9 feet, a plane is cut off. So a cone at the top, this small cone is cut off from the larger cone. Now with pi as 22 by 7, in cubic feet we are required to find out the volume of the remaining part of the cone. The remaining part of the cone is basically a frustum. So we are required to find out the volume of this part. Now what we will do is we will first initially calculate the volume of the larger cone. Then we will calculate the volume of the smaller cone, that is this cone. And the volume of the remaining part of the cone is just subtracting the two volumes. From the larger cone we will subtract the volume of the smaller cone. Now let us revise that the volume of a cone is equal to 1 by 3 into pi into r square into h, where r is the radius of the cone and h is its height. Now so calculating the volume of the larger cone is quite easy. We know that the radius is 4 and the height is 12. Now to calculate the volume of the smaller cone, do we know the height? We know the height is actually equal to 12 minus 9. This is equal to 3 feet. So the height of the smaller cone, this part is 3 feet. This we know quite easily. Now what is the radius of the smaller cone? The radius of the smaller cone we'll have to calculate. Now we'll draw a perpendicular line from the tip of the cone, that is the topmost point, to the bottom. So here we know that this is equal to 3 feet. We know that the area of the larger one is equal to 12 feet. We know that the radius of the larger cone is equal to 4 feet. We are required to find out the area of the radius of the smaller cone. You can calculate it by using simple property of similar triangles, because the smaller triangle is similar to the larger triangle. All their sides are in proportion. Therefore this small r by 3, which is the height of the smaller cone, is equal to 4 by 12, which is the height of the larger cone. Using this you can calculate that the radius of the smaller cone is actually equal to 1 feet. So now calculating both the volumes is quite easy. So volume of the larger cone is equal to 1 by 3 into pi into r square, where r is 4 into 4 into the height, which is 12. So 4 into 4 is 16, 16 into 12 is 192. So this is equal to 192 into pi by 3. This is the volume of the larger cone. Now volume of the smaller cone can be again calculated using the same formula. This is equal to 1 by 3 into pi into what is the radius of the smaller cone. We have just calculated that the radius of the smaller cone is 1 feet. So r square is 1 into 1 into what is the height of the smaller cone. The height of the smaller cone is 3. So this is equal to 3 into pi by 3. Therefore the volume of the remaining part of the cone is volume of larger cone minus volume of smaller cone. So this will be pi by 3 into 192 minus 3. This is pi by 3 into 189. 189 by 3 is 63. So the required answer is 63 pi, but because they have given us that the value of pi can be approximated to 22 by 7, we will use that. Again 63 by 7 is 9. So the answer is 22 into 9. Now 22 into 9 can be easily calculated as 198. So the required answer is 198 cubic feet. So
we can easily input that. To do that, we'll have to first figure out that to solve this question, that to calculate the volume of the remaining part of the cone, we just have to subtract the volume of the smaller cone from the volume of the larger cone. The second complexity over here is figuring out the radius of the smaller cone. You should understand that the radius and height of both the cones are in proportion, because the plane which is used to cut off the smaller cone is parallel to the base. So once you figure it out that the radius of the smaller cone is 1 feet, calculating the volume of the smaller cone and volume of the larger cone is quite straightforward. In this question, it is given that there is a parallelogram ABCD of area 72 square centimeters. So let us draw the parallelogram. This is the parallelogram. This is ABCD. The area of the parallelogram is 72 square centimeters. It is given that sides CD and AD have lengths 9 centimeters and 16 centimeters. So CD is 9 and AD is 16 centimeters. Let P be a point on CD such that AP is perpendicular to CD. So let P be a point such that AP is perpendicular to CD. So this is right angle 90 degrees. Then the area in square centimeters of triangle APD is. We are required to find out the area of triangle APD. It is a right angle triangle. We know the length of the hypotenuse, it is equal to 16 centimeters. So if we can figure out one of the lengths, that is either the base or the height, we can easily calculate the other side because using Pythagoras theorem. Then we can calculate its area easily. Now to find out the sides, you can notice that this is a parallelogram and the height of the parallelogram is actually equal to AP and the area is equal to base into height. So whenever you have a parallelogram, if the base of the parallelogram is B and the height, this height is equal to H, then the area is equal to B into H. Notice that we are looking at the height, we are looking at the perpendicular from the base to the other side, the parallel side. We are not looking at the length of the parallel side, we are only looking at a perpendicular from the base, that is this line which will intersect the other parallel side, that is called the height. In this case, the height is equal to AP, that is in parallelogram ABCD, the height is equal to AP and the base is equal to CD, and we know the length of the base, this is equal to 9 centimeters. So the area of the parallelogram will be base, that is 9 into the height, which is AP. We know that the area is 72. So 72 is equal to AP, which is the height, into the base 9. Using this, you can easily calculate that the length of AP is equal to 8 centimeters. Now once you know the length of AP, you can calculate the length of PD, because this is a right angle triangle in which the hypotenuse is equal to 16 centimeters. Therefore the length of PD is equal to square root of 16 square, which is the length of the hypotenuse, minus 8 square, which is the length of one of the sides. 16 square is 256, minus 8 square is 64. You can easily calculate that this will equal 8 root 3. Now we know PD, which is one of the base, and we know the length of the height also, that is 8 centimeters. Therefore the area of the triangle is equal to half into AP into PD. This is equal to half into 8 into 8 root 3. This is equal to 32 root 3 square centimeters. What we have done in this question is quite simple. We know the area of the parallelogram, we know the base. So once we know the base, we have calculated the height of the parallelogram. Once we calculated the height, we have calculated the length of the base of the triangle APD using Pythagoras theorem. Once we have the height of the triangle and the base of the triangle, because this is a right angle triangle, you can easily calculate its area, and this will equal 32 root 3 square centimeters. In this question, it is given that there is a circle with center O and radius 1 centimeter. So let us assume that this is the circle and this is the center O. An arc AB makes an angle 60 degrees at O. So as there is an arc AB, let us assume that this is the arc AB. This is A and this is B, and this is 60 degrees.
let R be the region bounded by radii OA, OB and RKB. So the region inside this is region R. C and D are 2 points on OA and OB respectively such that OC is equal to OD. So let us assume that this is C and say this is D. Now OC is given as equal to OD and the area of triangle OCD is half of that of R. So the area of OCD is half of that of R. Then the length of OC in centimeters is. So we are given that there is a triangle OCD of which two sides OC and OD are the same, and we are also given that there is a region of the circle where it has an angle of 60 degrees at the center. So what we will do first is we will calculate the area of the arc R, then we will calculate the area of triangle OCD and then try to understand what the length of OC will be. The first thing that you should notice is that triangle OCD is an equilateral triangle. Why is this an equilateral triangle? Because whenever you have a triangle where two sides are equal and the angle between them is 60 degrees, it has to be an equilateral triangle. Because when it is an isosceles triangle, because two sides are equal, and let us assume that this is x and this is x, because the angles beside the equal sides will be the same, then it would imply that 2x plus 60 degrees is equal to 180 degrees, because the sum of the angles of a triangle is 180 degrees. If you solve for it, x will equal 60 degrees. Therefore, all the three angles of the triangle will be 60 degrees. Therefore, it is an isosceles triangle. In case of triangle OCD here, OC is equal to OD and the angle in between them is 60 degrees. Therefore, triangle OCD is an equilateral triangle. Now, let us calculate the area of the region R. The area of region R will be 60 degrees, which is the angle at the center, by 360 degrees, which is the angle around a point, into the area of the triangle, area of the circle. And the area of the circle is pi r square, but r is equal to 1, so this will be pi into 1. So the area of R, the region R, will be pi by 6. As it is given that angle OCD has half the area of region R, area of triangle OCD will be pi by 6 by 2, so that is pi by 12. But we know that OCD is an equilateral triangle and we are required to find out the length of OC. So let us assume that OC is equal to x, therefore OD will be equal to x and CD will also equal x, as OCD is an equilateral triangle. The area of an equilateral triangle is root 3 by 4 into x square, where x is the side of the equilateral triangle. This is area of an equilateral triangle. So pi by 12 is equal to root 3 by 4 x square. You can simplify this, you can cancel 4 and 12, because 12 is equal to 3 into 4. Therefore, x square is equal to pi by 3 root 3, or x will equal pi by 3 root 3 whole to the power half. In this question, the most important thing is identifying that OCD is an equilateral triangle, because that makes things very easy. Once you identify that, you can just calculate the area of region R and equate it after knowing the formula for the area of an equilateral triangle. Then you can easily find out the length of OC, which in this case is equal to pi by 3 root 3 whole square root to the power of 1 by 2.
We at Krakow provide all the previous year CAT papers along with many other MBA examinations such as IIFT, ZAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.
In this question, it is given that there is a parallelogram ABCD of area 48 square centimeters. So let us assume that this is the parallelogram. This is A, this is B, this is C and this is D. We are told that the length of CD is 8 centimeters and the length of AD is equal to S. Then which of the following is necessarily true? So if you look at the options, we are required to find out the range for S. So we are given that the area of the parallelogram is 48 square centimeters and we are given the length of the base, this equals 8 centimeters. So we know that the area of a parallelogram is equal to base into height. So what exactly is height? Height is the length of the perpendicular that is drawn to the base from one of the vertex. So let us assume that this is equal to h. What we are given is that 8 into h, 8 is the base and h is the height of the parallelogram, is equal to the area, which is 48, or we are told that h is equal to 6 centimeters. So basically we are given a parallelogram where the height of the parallelogram is 6 centimeters. We are required to find out the range of S. Now suppose the point at which the perpendicular is dropped on CD is E. Now if you consider triangle ADE, this is a right angle triangle. In this we know that the height of the triangle, that is one of the sides of the right angle triangle, is 6 centimeters, and we are required to find out the range of S. S is the hypotenuse of the right angle triangle. So hypotenuse will always be the longest side of the right angle triangle. So we know for sure that S is greater than or equal to 6. Should S be always greater than 6? That is not necessarily true, because every rectangle is also a parallelogram. So if the parallelogram that is mentioned is like this, where this is 8 and this is S and this is already a right angle, then the value of S over here will equal 6 centimeters. What we know for sure is that S has to be greater than or equal to 6, because S has to be greater than or equal to the height of the parallelogram, or in this case the height of the triangle. So if you look at the options that are given, one of the options, for example option D, is S is less than or equal to 6. This is definitely not true. The second one is S is not equal to 6. This also is not necessarily true, because as we discussed earlier, if it is a rectangle, then S will equal exactly 6. The third one that you can strike out is option C, which says that S has to lie between 5 and 7. This is also not necessarily true, because S first of all cannot be less than 6. So S can't exist between 5 and 6, and there is no necessary upper limit for S. For example, if the parallelogram that we are considering is very acute, in a case where, say, this is the parallelogram where the angle ADA, if this is very low, then the length of S will be very large. The height will ultimately come down to 6, but the length of the hypotenuse can be very large. So there is no necessary upper bound for S. So we can even strike this out. The only correct answer over here is that S is greater than or equal to 6. This is something that we can say for certain. We know that S has to be greater than the height of the parallelogram, which is equal to 6. So the correct answer in this case is option B. In this question it is given that there is a chord of length 5 centimeters. It subtends an angle of 60 degrees at the center of the circle. So suppose this is the circle. Now there is a chord and this is the center of the circle. Suppose that this chord is subtending an angle of 60 degrees and the length of the chord is given as 5 centimeters. Now whenever you are told that there is a chord which subtends 60 degrees, or if you are told that there is a triangle, in this case it is an isosceles triangle because both the radii are equal. So whenever you are told that there is an isosceles triangle and the angle between the equal sides is 60 degrees, you can be sure that this is an equilateral triangle, because when this is an isosceles triangle, the base angles will be the same. Let us assume that they are equal to A. Therefore 2A plus 60 degrees will equal 180 degrees, which is the sum of all the angles of a triangle, or you can infer that A will also equal 60 degrees in this case. So all the three angles will equal 60 degrees and hence it is an equilateral triangle. So in this case also, because it is given that the length of the chord is 5 centimeters and it subtends an angle of 60 degrees, this will be an equilateral triangle, and the radius of the triangle, the radius of the circle, is equal to 5 centimeters. Now the length in centimeters of a chord that subtends an angle of 120 degrees at the center of the same circle is, so we are required to find out the length of another chord, but this one subtends an angle of 120 degrees at the center. So as we have discussed earlier, the radius of the triangle is 5 centimeters and this chord subtends 120 degrees at the center. So let us assume that the length of this chord is equal to x. Let us draw a perpendicular from the center to the center of the chord. Again, you should remember that whenever there is a circle, if there is a chord, the perpendicular from the center of the circle to the chord will bisect the chord. So whenever you are drawing a line from the center of the circle to the midpoint of the chord, it will be 90 degrees. So over here the length of, so suppose this is O, this is A, this is B and this is C. So in triangle OAC, the length of AC is equal to x by 2. As we have discussed earlier, this will be the midpoint of the chord, and we know that the angle is bisected. So angle AOC is 60 degrees because the bigger angle, that is angle AOB, is equal to 120 degrees. Therefore, we can infer that the other angle is 30 degrees because this is a right angle triangle. What is this angle? This angle is angle OAC is equal to 30 degrees. Now you can easily find out the value of x by 2 in multiple ways. For example, in this case, x by 2 is equal to 5, which is the hypotenuse, into sine 60 degrees. So if you are considering this angle, in this triangle, the triangle OAC, the hypotenuse is 5 centimeters, the length of the base is x by 2, and this is 60 degrees. So you can easily find out that x by 2 will equal 5 into sine 60 degrees. Sine 60 degrees is equal to 5 into root 3 by 2. You can cancel the denominator 2 on both sides. Therefore, the length of x will be 5 root 3. That is, the length of the chord AB will be 5 root 3. There are a couple of things that we have learned in this question. One is that when there is a triangle, an isosceles triangle, and the angle between the equal sides is 60 degrees, it is an equilateral triangle. The second thing which you should remember is whenever you draw a line from the center of the circle to the midpoint of any chord, it will be a perpendicular line to the chord. Once you know these two things, finding the value of the chord will be very straightforward, which in this case is 5 root 3. In this question, it is given that there is a rectangle. The area of the rectangle and its perimeter, the square of its perimeter, are in the ratio 1:25. So let us first look at the rectangle. Say this is the rectangle. Let the sides of the rectangle be A and B. Therefore, the area of the rectangle will equal AB, and the perimeter of the rectangle will equal 2 into A plus B. Therefore, the square of the perimeter will equal 4 into A plus B whole square. Now, we are told that the area of the rectangle and the square of its perimeter are in the ratio 1:25. So, AB by 4 into A plus B whole square is equal to 1/25. This is the equation that is given to us. We are required to find out the lengths of the shorter and longer side are in the ratio. So, we are required to find out the ratio of A is to B, where we can assume that A is greater than B. So, let us first try to simplify the equation that is given and then try to find out what is needed. So, this would imply that 25AB is equal to 4A square plus 8AB plus 4B square, or this will imply that 4A square minus 17AB plus 4B square is equal to 0. Now, we are only looking at the larger and the shorter side. We are not really concerned about the exact values of A and B. They can be even interchanged. So, without loss of generality, let us assume that A is greater than B, and let A by B be equal to R, and we are required to find out the value of R. Now, because A is greater than B, R is greater than 1. So, we are actually required to find out the lengths of the shorter to the longer side. So, we are required to find out the value of 1 by R. We will keep that in mind while we try to simplify this equation. So, we will divide this equation by B square. So, it will become 4 A by B whole square minus 17 A by B plus 4 is equal to 0. Now, as we have assumed that A by B is equal to R, this would equal 4R square minus 17R plus 4 is equal to 0. This is a simple quadratic equation in R. You can solve for R and then you can get the answer. In this case, we can factorize this as 4R square minus 16R minus R plus 4 is equal to 0, or 4R into R minus 4 minus 1 into R minus 4 is equal to 0. So, this will be 4R minus 1 into R minus 4 is equal to 0, or R will equal 1 by 4 or 4. So, as we have assumed that A is greater than B, R will be greater than 1. So, the ratio of the longer to shorter side is equal to 4:1. But what is asked over here is the ratio of the shorter to the longer side. So it will be the exact opposite. So the answer in this case will be 1:4. In this question, it is given that there is a triangle ABC, and using the side BC as diameter, a circle was drawn, and this intersects AB and AC at points P and Q respectively. So just putting that whatever information is given in the form of a diagram, we have BC, which is the diameter of a circle, and we have a triangle ABC. So this is triangle ABC. Using BC as the diameter, we drew a circle. This intersects AB and AC at P and Q. Now we are given the lengths of AB. AB is given as 30 centimeters. We are given the lengths of AC. AC is equal to 25 centimeters. And we are given the length of CP. CP is given as 20 centimeters. We are required to find out the length of BQ. What is the value of BQ? So let us first connect BQ and CP, because that is what we are required to find out. Now once we connect, the first thing that we should observe is that angle BPC will be 90 degrees. Similarly, angle BQC will be 90 degrees. Why will this be 90 degrees? Because in any circle, once you draw the diameter and you connect both the ends of the diameter to any point on the circumference, this will be 90 degrees. It can be any point on the circumference. So it can be, say, this point or any point. This is going to be 90 degrees. So over here, angle BPC is equal to angle BQC is equal to 90 degrees. Now once you have it, you know the length of AB, you know the length of CP, similarly you know the length of AC, and we are required to find out the length of BQ. So immediately something that should strike you is that we have the base and we have the height. So if you want to find out the area of triangle ABC, this is going to equal AB, which is the base, into CP, because CP is the perpendicular from AB. This is half into base into height. Similarly, this will actually equal half into AC, if you consider AC as the base, that is this side, and BQ as the height, into BQ. So both of them should be equal. That is, AB into CP should equal AC into BQ. We'll use that to find out the answer. AB is equal to 30 into CP is equal to 20. This equals AC is equal to 25 into BQ. Now you can cancel 5 on both sides. So BQ will equal 24 centimeters. So the answer in this case is 24 centimeters. In this question, it is given that there is a triangle ABC. The area of the triangle is given as 32 square units. Its side BC of length 8 units lies on the line x is equal to 4. So let us first draw the graph. We will try to understand what this actually represents. So this is the y-axis and this is the x-axis. Now x is equal to 4 is a line over here. This is x is equal to 4. Now on this line lies the side BC. So BC can be anywhere on this line. The length of BC is 8 units. Now the shortest possible distance between A and the point 0, 0 is. So let us first try to find out where the vertex A can lie, because we know the area of ABC is given as 32 square units. We know that the length of BC is given as 8 units. So if you consider ABC to be something like this, this is A. Just for ease, let us consider ABC to be like this. This is A, this is B, and this is C. We are told that BC is equal to 8 units, and we know that the area is 32 units. So the perpendicular from A to BC, we can easily find out the length of that perpendicular. If you assume that the length of that perpendicular is x, half into x into 8 will be the area of ABC. But this we already know is equal to 32. It has already been given that the area is 32 square units. So this would imply that x is equal to 32 into 2 by 8. You can simplify this and this will be 8 units. So the height of the altitude from A is 8 units. So because you know that BC is lying on the line x is equal to 4, it would imply that because BC is lying on the line x is equal to 4, it would imply that the vertex A lies on either x is equal to 12 or x is equal to minus 4, because you know that the altitude is 8 units. So if you draw the line x is equal to minus 4, it will be something over here. This is the line x is equal to minus 4, and the line x is equal to 12 will lie somewhere over here. Now if you pick any point on any of these lines and BC, the area of the triangle will definitely be 32 units. For example, if you assume that this is point A and you join A to BC, because the height is constant, the height is 8 units and the base length is also 8 units, the area of this triangle will be 32 units. Similarly, if you pick any point over here on the line x is equal to minus 4 and you join it, again because the height is fixed as 8 units, this height, and the base we already know is also 8 units, it would again imply that the area of this triangle is also 8 units. So we need to fix the point A on either x is equal to minus 4 or x is equal to 12. But we have to do it in such a way that the distance between A and origin, that is point 0, 0 is the least. Now for the point 0, 0, the distance is least from x is equal to minus 4 if A is minus 4, 0, in which case the distance is 4 units. Similarly, if you are trying to fix A on the line x is equal to 12, the shortest distance from origin to the line x is equal to 12 will be when A is 12, 0, and in this case the distance is 12 units. Because you are trying to minimize this distance, the answer will be 4 units, and this will happen when A is the point minus 4, 0. Notice that we have finalized that A lies, that is the vertex A lies either on x is equal to minus 4 or on x is equal to 12. Now when A lies on x is equal to minus 4, the shortest possible distance between origin and x is equal to minus 4 is 4 units. This will occur when A is minus 4, 0. If A lies on the line x is equal to 12, the shortest possible distance is 12 units, and this is when A is 12, 0. Because we are trying to minimize it, the answer will be 4 units. In this question, it is given that there is a rectangle ABCD and the area of the rectangle is 768 square centimeters. So let us first draw the rectangle. See, this is the rectangle ABCD. The area of the rectangle is 768 centimeters square. Now a semicircular part of diameter AB and area 72 square centimeters is removed. So a semicircle with AB as the diameter and the area is given as 72 square centimeters is removed. Now we are required to find out the perimeter of the leftover portion. So the leftover portion will look something like this. This is ABCD. I am making this look slightly smaller for scale. Okay, so this is A, this is D, this is C, this is B. We are required to find out the perimeter of this part. So what we'll do is quite simple. We'll first assume that the length of AB is L and the breadth of AB is B. So we know that L into B is given as 768 centimeter square. But we are also given that the area of the semicircle is 72 pi. Now for the semicircle, the radius, AB is the diameter, so the radius will be AB by 2, which is L by 2. Therefore the area of the semicircle will be pi r square by 2, but in this case r is equal to L by 2. So this will be pi by 2 into L by 2 into L by 2. This we are told is equal to 72 pi. Therefore you can solve for it and you will find that L square is equal to 144 into 4. So L is equal to 12 into 2, which is equal to 24 centimeters. So now that we know L, we will calculate the value of B. B is equal to 768 by L, which is equal to 768 by 24. You can easily calculate that this is equal to 32 centimeters. Now if you are required to find out the perimeter of this figure, you know that the length of AD is 32 The length of BC is also 32. The length of CD will equal the length of AB, which will equal 24. So you are just required to find out the circumference of the semicircle. Now circumference of the semicircle, circumference of the entire circle will be 2 pi r. This is for the full circle. So the perimeter of the semicircle will be half of it, which is equal to pi r. In this case, r is equal to L by 2. So this will be pi into L by 2, where L is equal to 24. So this will equal 12 pi. So the length of this circular part is 12 pi. Therefore the total perimeter will be 32 plus 32 is 64, 64 plus 24 is 88, 88 plus 12 pi. So the answer is 88 plus 12 pi. In this question, we are required to find out the area of the closed region bounded by the equation modulus of x plus modulus of y is equal to 2 in the two-dimensional plane. So if you look at the equation modulus of x plus modulus of y is equal to 2, it contains 4 lines. The equations of the 4 lines are x plus y is equal to 2, x minus y is equal to 2, minus x plus y is equal to 2, and minus x minus y is equal to 2. Now let us draw the 4 lines. Let us see what is the region which is enclosed by these 4 lines and then find out the area of that region. So let us first draw the x and y axis. The simplest of the 4 lines is x plus y is equal to 2. It will be a line which will be something like this. It will have a y-intercept of 0, 2 and an x-intercept of 2, 0. Similarly, minus x minus y is equal to 2 is just x plus y is equal to minus 2. This will be something like this. This will have an x-intercept of minus 2, 0 and a y-intercept of 0, minus 2. You can easily find out the other 2 lines. This is x minus y is equal to minus 2 and this is x minus y is equal to 2. So as you can see, this is a square. The region that is bounded by these 4 lines is a square. Now we can easily find out the side of the square. This is the side of the square. We know that the height of the right angle triangle is 2 and the base of the right angle triangle is also 2. So the side of the square, which is the hypotenuse of the right angle triangle, is 2 root 2. Therefore the area of the square, which is the region that is enclosed by these 4 lines, is 2 root 2 into 2 root 2, which is equal to 8 square units. In this question, it is given that there is a triangle ABC with sides 40 feet, 25 feet and 35 feet. A triangular portion GBC is cut off where G is the centroid of ABC. We are required to find out the area of the remaining portion of triangle ABC. So let us first draw the rough diagram to understand what exactly is given and what exactly is asked. So suppose this is ABC and suppose this is G, which is the centroid. It is mentioned that this triangle GBC is cut off and we are required to find out the area of the remaining triangle. So what we will do first is we will find out the area of the original triangle ABC. Then we will find out the area of GBC, of triangle GBC, and then we will just subtract 2 from 1 to get the answer. Now finding out the area of ABC is very easy. We have all the 3 sides, 40 feet, 25 feet and 35 feet. So S, which is the semi perimeter, is the sum of all of them, that is 40 plus 25 plus 35 divided by 2. So if you calculate it, this will be 50. Therefore the area of ABC is equal to square root of S into S minus A into S minus B into S minus C, where ABC are the lengths of the sides of the triangle. So this is square root of 50 into S minus A is 50 minus 40, so that is 10, into S minus B is 50 minus 25, that will equal 25, into S minus C is 50 minus 35, so that is 15. So this can be simplified as 5 into 10 into square root of 75. 5 into 10 into square root of 75. Again we can take 25 out of the square root. So this will be 250 root 3. This is the area of triangle ABC. Now we need to calculate the area of GBC. Now one thing we know about the median which passes through the centroid is that the median will be intersected in the ratio of 2:1. It will be divided in the ratio of 2:1 by the median. So if you are looking at, suppose the midpoint of BC is say D. Now draw an altitude from A to BC. I will draw these lines again to get a better understanding. Suppose this is GBC, this is G, this is B, and this is C. Suppose this is the midpoint of BC. It looks bad, but just stay with me. And suppose this is the perpendicular. Now extend this further so that this is A, and draw a altitude from A to BC. Now suppose the midpoint is say D, the perpendicular from G, suppose it meets BC at E, and suppose the perpendicular from A meets BC at say F. What we are trying to understand, what we are trying to prove from this is the height of GBC, the smaller triangle, is 1/3 the height of the bigger triangle ABC. So the area of JBC will be 1/3 the area of ABC. This is what we are trying to prove. And this is quite easy to prove, because if you look at it, suppose this is 1 and this is 2, that is GD is 1 and AG is 2, and let the height of GE be H1 and let the height of AF be H2. Now triangle ADF is similar to triangle GDE, because both of them are right angle triangles which share a common angle D. So both of them are actually similar triangles. So H1 by H2 will equal DG by AD. That is, the height of the triangle GBC by the height of the original triangle is equal to GD by AD. Now GD by AD is 1/3, because we know that GD is 1 and AG is 2, so AD will be 3. Therefore H1, that is the height of the smaller triangle, will be 1/3 the height of the bigger triangle. Therefore the area of GBC will be 1/3 the area of ABC. So the remaining part of the triangle ABC will be 2/3 the original area of triangle ABC, which is 250√3. So the required area, which is the area of the remaining part, will be 500 by square root 3. This is the answer. All that we need to solve this is understand that the height of the smaller triangle, the triangle which passes through the centroid, is 1/3 the original height of the triangle. So the remaining area is 500 by root 3. In this question it is given that ABC is a right angled isosceles triangle with hypotenuse BC. So this is AB, this is a right angle triangle, this is also an isosceles triangle, the hypotenuse is BC. So AB is equal to AC, as this is isosceles. BQC is a semicircle away from A with diameter BC. So with diameter BC there is a semicircle BQC. Let BPC be an arc of a circle centered at A and lying between BC and BQC. So keeping A as the center, we have to draw an arc which connects B and C as part of a circle. Now this is BPC. If the length of AB is 6 centimeters, so AB is 6 centimeters, therefore AC will also be 6 centimeters. The area in square centimeters of the region enclosed between the two curves BPC and BQC is what? So to solve this, first we will calculate the area of the semicircle BQC. Then we will subtract the area of the small arc BPC from it. But how do we calculate the area of the small arc BPC? To do that, we will calculate the area of APC, that is this larger area. This is quite easy to calculate because this is part of a circle. So we will calculate APC and we will subtract the area of the triangle ABC from it, minus area of ABC. This is the area of BPC that you want, and once we calculate this, we will subtract it from the area of the semicircle BQC. So first, calculating the area of the semicircle BQC, you need the radius of BQC. The diameter of this semicircle is the hypotenuse BC. The length of BC, because this is a right angle triangle, is 6 root 2. Note that AB is equal to AC is equal to 6 centimeters. So the hypotenuse BC will be 6 root 2. This is the diameter. So the radius of BQC is equal to 3 root 2. And the area is equal to pi r square by 2. Again, this is a semicircle and not a circle. So the area will be pi r square by 2. So this is equal to pi into 3 root 2 into 3 root 2 by 2. You can cancel root 2 and 2, and so this will be 9 pi. So we have found out the area of the semicircle, the outer semicircle BQC. From that we will have to subtract the area of BPC. Now again, to calculate BPC, we will first calculate the area of APC. APC is an arc which is leaving 90 degrees at the center. This is part of a circle which is leaving 90 degrees at the center. Therefore, the area of the chord APC, area of this sector APC will be 90 degrees by 360 degrees into pi r square. Now what is the radius of this circle? The radius of this circle is equal to AB or AC. This is equal to 6. So this is 1 by 4 into 36 pi. This is equal to 9 pi. 9 pi is the areas of the larger sector APC. From this we will subtract the area of the triangle ABC. Area of triangle ABC is half into base into height. This is half into 6 into 6. This is equal to 18 square centimeters. Therefore, area of BPC, that is this smaller part, is equal to 9 pi minus 18. This we have to subtract from BQC to get the area of the remaining region between BPC and BQC. So that is quite easy. So it will be 9 pi minus of 9 pi minus 18. You can cancel 9 pi and the answer will be 18 square centimeters. In this question we are told that there is a solid metallic cube. It is melted to form 5 solid cubes whose volumes are in the ratio 1:1:8:27:27. Now let us assume that the 5 solid cubes, the volumes are actually A cube, 8A cube, 27A cube and 27A cube. Now the volume of the original cube will be the sum of all these volumes because the volumes will not change. So the volume of the original cube will be A cube plus A cube. This is 2 plus 8, 10. 10 plus 54 is 64 A cube. This is the volume of the original cube. It was divided into 5 cubes of the respective volumes. Now the percentage by which the sum of the surface areas of these 5 new cubes exceeds the surface area of the original cube is. So we will first find out the surface area of the original cube. We will find out the surface area of each of the smaller cubes and then we can find the answer quite easily. If this is the volume, let us find out the individual sides. So because the volume of the first cube is A cube, the side is A. Similarly, the second one also side is A. The third cube, the side is 2A. For the fourth cube, the side is 3A, and for the fifth cube, the side is 3A. Similarly, the side of the larger cube is 4A. Remember that the volume of a cube is equal to S cube, where S is the side of the cube. Now let us calculate the total surface area. Again, the formula for the total surface area of a cube of side S is equal to 6S square. So for each one of them, let us calculate the total surface area. For A, it will be 6A square. Again, it will be 6A square. Here it will be 6 into 2A square, that is 6 into 4A square, so that is 24A square. This is 6 into 9A square, so that will be 54A square. This also will be 54A square. And the total surface area of the original cube is 6 into 4A whole square. So this is 6 into 16A square, so that is equal to 96A square. So the original surface area of the cube is 96A square. The new total surface area will be the sum of all of this. So 6 plus 6 is 12, 12 plus 24 is 36, 36 plus 108 is 144A square. This is the new total surface area. Now the percentage by which this exceeds 96 is 144 by 96 minus 1. 144 by 96 is 3 by 2 minus 1. So this is equal to half or 50%. So the answer in this case is 50%.
So this question is this question looks like it's a question on solids, but it's actually not. A ball of diameter 4 centimeters is kept on the top of a hollow cylinder standing vertically. The height of the cylinder is 3 centimeters while its volume is 9 pi cubic centimeters. Then the vertical distance in centimeters of the topmost point of the ball from the base of the cylinder is. Let's start by first drawing this out. So we have this cylinder like this, which is 3 centimeters. So this is the base, and we have a ball of. Actually, I'll remove this because I need to draw the ball also. So this is 3 centimeters long, and there's a ball which has a diameter 4 centimeters. So the diameter will lie slightly outside the top of the cylinder. So the diagram will be somewhat like this, where this 3 centimeters will be a chord of the circle as such. The height is 3 centimeters. We don't know the radius of the cylinder, but the diameter of the cylinder will be a chord of the circle, and we know that the diameter of this ball is 4 centimeters. So this radius is 2 centimeters. As you can see, to find the this length, we have to find the length from the top of the ball to the base of the cylinder. So we are going to find this length as such. But to find this length, we just need the 2D cross section. We do not need the solid as such entirely to find the height of the solid. So all we needed was this 2D cross section as such. Now we have to find out this length as such. So first let's find out what is the radius of the given cylinder, because the radius of the cylinder is essentially forms this chord as such. We are given that the volume of the cylinder is 9 pi cubic centimeters. The formula for the volume of the cylinder is pi r square h, and h is given as 3. So we substituting this, we get 9 pi is equal to 3 pi r square. So r square is equal to 3, or r is equal to root 3. So this is equal to root 3. So this is a right angle triangle with because this is a chord. So a line joining the midpoint of the chord to the center of the circle will be perpendicular to the chord as such. So this is a right angle triangle with hypotenuse 2, and one side is root 3. So the other side will be 2 square minus root 3 square. That is essentially 1. So this length is 1. So we get this length as 1. This is the other radius. So this is 2, and this is the height of the cylinder, that is 3. Therefore, the length of the distance in centimeters from the topmost point of the ball to the base of the cylinder, this distance is equal to 2 plus 1 plus 3, that is 6 centimeter. As you could see, this became very simple once we drew the diagram. Whenever they are asking you not to find like the volume or anything of that sort, they are just asking you to find the distance or the length or something of that sort. Always remember that most of the times you just have to consider the 2D cross section of it. In this case, like you had this, in this case you had a cylinder, a hollow cylinder, and a ball resting on it. So if you had sliced that cylinder in the middle, like this entire figure in the middle, then you would have gotten the topmost point at the top as shown in the figure, and you would have gotten the base of the cylinder. So if you had sliced in the middle, you would have gotten this 2D cross section. And once you have this 2D cross section, it just is a basic, you just have to apply basic geometry fundamentals for circles and for chords as such to find out this length as such. So you needed fundamentals of how to find the basic idea about chords as such, that the line joining the midpoint of the chord to the center of the circle is perpendicular to the chord. You needed how to find the volume of a cylinder, the formula for volume of a cylinder, and just using that basic information you could easily calculate the distance of the topmost point of the ball to the base of the cylinder as such. So it required some basic formulae, but if you knew the formulas that are required in geometry, you would have been easily able to solve this question as such.
In this question we are given that ABC is a right angle triangle with B as the hypotenuse. So let this be ABC this is BC is the hypotenuse, so this is BC and A is the right angle. The lengths of AB and AC are 15 and 20 kilometers. So AB is 15 kilometers, AC is 20 kilometers. Therefore, BC has to be 25 kilometers. This is using simple Pythagoras theorem, that is 15 square plus 20 square. This will equal 25. The minimum possible time in minutes required to reach the hypotenuse from A at the speed of 30 kilometers per hour is. So whenever you are required to find out the minimum possible time, you have to first figure out what is the distance from this point A to the line BC. If you need the distance, you want to draw a perpendicular from A to BC, and the length of the perpendicular will be the shortest distance between a point and a line. So let us assume that it meets the hypotenuse BC at D. So what we are required to calculate is the length of AD. This is the shortest distance from A to BC. Now calculating AD is not very difficult. Let us assume that the angle at B is theta. Now in triangle ABC, tan theta is opposite side, that is 20, by the adjacent side, that is 15. So this is equal to 4 by 3. Similarly, as we have calculated that the hypotenuse BC is equal to 25 kilometers, cos theta is equal to adjacent side, that is 15, by hypotenuse, that is 25. This is equal to 3 by 5. Now in triangle ABD, we are required to find out the length of AD. So AD by AB, AD over here by AB is equal to sin theta, because in this case AD is the opposite side of angle theta, and using cos theta as 3 by 5, we can calculate that sin theta will equal 4 by 5, because we know that sin square theta plus cos square theta is equal to 1. So as you know that cos square theta is 3 by 5, you know that sin square theta will be 4 by 5. So as AD by AB is sin theta, we know that AD is equal to AB into sin theta. AB is 15 into 4 by 5, this is equal to 12 kilometers. There are a number of ways in which you can calculate the length of AD. You can either use trigonometry as we have used now, or you can use the fact that triangle ADB is similar to the bigger triangle ABC, because all the angles will be the same. For ADB, the angles are theta, 90 and 90 minus theta. Similarly, for triangle ABC also, the angles are theta, 90 and 90 minus theta. As they are similar triangles, the lengths of the sides are in ratio of are in proportion. The lengths of the sides which are opposite the same angles. So for example, in ADB, the angle which is opposite theta is AD, and in ABC, the side which is opposite theta is 20. So AD by 20 will equal, in ADB the hypotenuse is 15, and in ABC the hypotenuse is 25. So if you use this also, you can calculate the length of AD. So again AD will be equal to 15 into 4 by 5. This is equal to 12 kilometers. Once you have calculated the length of AD, finding the time required to reach the hypotenuse is quite simple. You are given the distance, you are given the speed as 30 kilometers per hour. So the required time will be 12 by 30 hours. So if you want it in minutes, it will be 12 by 30 into 60. So that is equal to 24 minutes. So the answer in this case is 24. In this question, you are given a curve y is equal to modulus of x minus 1 plus modulus of x plus 1, and we are required to find out the shortest distance of the point half comma 1 from this given curve. So let us first draw the graph of the curve, understand how the graph actually looks, and then try to calculate the shortest distance. So if you are looking at the curve, y is equal to modulus of x minus 1 plus modulus of x plus 1. Clearly this graph has two inflection points. What are the two inflection points? That is the 2 points which are important to consider. that is when x minus 1 and x plus 1 equals 0. So that is when x is equal to 1 and x is equal to minus 1. At this point the modulus becomes 0 and just ahead of it will be negative and just in front of it will be positive. So let us first consider the three cases. Case 1 is when x is less than minus 1. Case 2 is when minus 1 is less than x is less than 1. And case 3 is when x is greater than 1. So for two inflection points we are getting three regions. We will draw the graph in the three regions and then see how it looks overall. So let us first draw the x and y axis. This is x is equal to minus 1 and this is x is equal to plus 1. Now when x is less than minus 1, modulus of x minus 1 will be 1 minus x and modulus of x plus 1 will be minus 1 minus x, because both of them will be negative. So y will equal minus of 2x, because y will equal 1 minus x minus 1 minus x, so overall it will be minus 2x. So whenever x is less than minus 1, the graph will look something like this. It will be a straight line, and when x is equal to minus 1, y will equal 2. So it will be a straight line and the slope of the straight line will be minus 2 and it will stop at y is equal to 2. Now when x is in between minus 1 and plus 1, modulus of x minus 1 will equal 1 minus x, again because this will be negative, but modulus of x plus 1 will be x plus 1, because when x lies between minus 1 and plus 1, x plus 1 will be positive. So modulus of x plus 1 will be x plus 1 itself. Therefore y, which is equal to modulus of x minus 1 plus modulus of x plus 1, will equal 2. So between minus 1 and plus 1, the graph will be a straight line which is parallel to x axis, and this will equal 2. Similarly, when the third case, that is when x is greater than 1, both modulus of x minus 1 will be greater than 0, so this will equal x minus 1, and modulus of x plus 1 will also be greater than 0, so this is also equaling x plus 1. Therefore y, which is the sum of these two, will equal 2x. So whenever x is greater than 1, again it will be a straight line, the slope of the straight line will be 2. So this is how the graph y is equal to modulus of x minus 1 plus modulus of x plus 1 looks like. Now where is the point half comma 1? Half comma 1 will be when x is equal to half, and the y axis, the point on the y axis will be 1. So you can see that the distance between the point and the graph, the shortest distance, is when you draw a perpendicular to the line y is equal to 2. That is when you draw a perpendicular to this line, and the distance will be, because the overall height is 2 and the point itself is at 1, the distance between the point and the graph will be 2 minus 1, which is equal to 1 unit. This will be the shortest distance of the point from the graph, from the curve. So the answer is 1. To solve this, first we have to draw the graph. Once we understand the graph and where the point lies, you can easily find the shortest distance, because the height of the line y is equal to 2 is 2 and the point is already at 1. The remaining distance is 1 unit. So the answer is 1. In this question we are told that ABCDEF is a regular hexagon with side length of 1 centimeter. So let us assume that this is the regular hexagon A, B, C, D, E and F. We are required to find out the area in square centimeters of a square where AC is one side. So we are assuming that AC is one side of a square and we are required to find out the area of the square. We know that area of a square is equal to L square, where L is one of the sides. So if you are able to find out the length of AC, we will easily calculate the area of such a square. We know that AB is equal to 1 and AC is equal to 1. We know that angle ABC is 120 degrees. Because this is the interior angle of a regular hexagon, the angle will be 120 degrees. So we need to calculate the length of AC. we'll just draw ABC for ease of understanding this method. Remember that you can use the cosine rule to calculate the length of cosine law to calculate the length of AC, but we'll try to not use it because there's a much easier way to calculate it. This is ABC. We know that AB is 1. We know that BC is 1. We'll draw a perpendicular from B to C. Let us assume that this is D. Because this is an isosceles triangle, this will also be the midpoint of AC. And this is 60 degrees and this is 60 degrees. This is 90 degrees. So BAD will be 30 degrees. So you can easily figure out that AD is equal to the length of hypotenuse AB into cos 30 degrees. We already know that AB is equal to 1. So AD will be root 3 by 2. That is AD is root 3 by 2. Therefore CD will also be root 3 by 2. And the length of AC will be root 3 by 2 plus root 3 by 2, which is equal to root 3. Therefore the area of the square is L square. So it will equal 3. In this question it is given that there is a vertical pillar and the uniform cross section is a trapezium with parallel sides equal to 10 centimeters and 20 centimeters, while the other two sides are of equal length. So let us first draw the cross section of the trapezium. So this is the cross section of the trapezium. It is given that this is an isosceles trapezium in the sense that the non-parallel sides are of equal length and the lengths of the parallel sides are 10 and 20. The perpendicular distance between the two parallel sides of the trapezium is 12 centimeters. So we are told that this is equal to the height of the trapezium is 12. Once you know the height, you can easily calculate the base of the trapezium because the parallel sides are of 10 and 20. If you assume that these are A and AH, which is the intersections after you cut the smaller side from the larger side, 2A is equal to 20 minus 10, which is the difference between the lengths of the parallel sides. That is, this length A and A is equal to 20 minus 10. From this, you can easily calculate that A is equal to 5 centimeters. Now, if you look at the right angle triangle, the base of the right angle triangle is 5 and the height is 12. Therefore, the hypotenuse can be easily calculated as square root of 5 square plus 12 square, that is square root of 169 or 13 centimeters. Remember that 5, 12 and 13 are a Pythagoras triplet. Similarly, on the other side also, you know that the hypotenuse of this triangle is 13. So, the trapezium will look something like this after you have calculated all the sides. One side is 10, the other side is 20, and the lengths of the isosceles non-parallel sides are 13 and 13, and the perpendicular distance is 12. All this is already given in the question. And this equals 10. Now, we are told that the height of the pillar is 20 centimeters. We are required to find out the total area in square centimeters of all the 6 surfaces of the pillar. So, if you look at the height of the pillar as 20 centimeters, there will be 4 sides which are in the vertical direction. One side will be of length 13 centimeters and the height will be 20 centimeters. The other one will be the exact opposite side. Again, the base will be 13 centimeters and the height will be 12 centimeters. Same with even the non-parallel sides, that is the base will be 10 centimeters and the height will be 20 centimeters. Similarly, the larger one, which is the base is 20 centimeters on the floor and 20 centimeters in the vertical direction. So these will be the 4 sides, 4 surfaces in the vertical direction. And there will be 2 surfaces which will be parallel to the ground, which will be in the horizontal direction. They will be basically the face of the trapezium. So we'll calculate the area of the trapezium, we'll multiply it by 2, so that will be the bottom and that will be the top, and there will be 4 sides on each sides of the trapezium, where the height of the trapezium is 20 centimeters. The height of the surface is 20 centimeters. So if you are calculating the 4 perpendicular surfaces, the area of the 4 perpendicular surfaces, it will be 10 into the height of the vertical pillar is 20. So that is 10 into 20 plus 13 into 20. So it will be this 13 into 20 in the vertical direction plus 13 into 20. This is for the other isosceles non-parallel side. and finally the larger the larger side which is parallel, which is 20 centimeters on the base and 20 centimeters above the ground. So that will be 20 into 20. These are the four surfaces which are in the vertical direction, which are perpendicular to the ground. Now if you are looking at the two surfaces which are parallel to the ground, they will be basically the area of the trapezium. Now area of the trapezium is quite easy to calculate. It is the average of the lengths of the parallel sides into the height. So if you are looking at the average of the lengths of the parallel sides, it is 10 plus 20 by 2 into the height, which is 12. So this will be 10 plus 20 is 30 by 2 is 15 into 12 is 180 centimeters. So each of the surfaces which are parallel to the ground will have a area of 180 centimeters. So the total area of the 6 surfaces of the pillar will be 10 into 20 is 200 plus 13 into 20 is 260 plus 13 into 20 is another 260 plus 20 into 20 is 400 plus there are two surfaces of 180 centimeter square each. So this will be 360 centimeter square. This will be the total area. You can easily simplify this. 260 plus 260 is 520. 520 plus 600 is 1120. 1120 plus 360 is 1480 centimeter square. So the area of all the 6 surfaces is 1480 centimeter square. In this question, we are given that there is a rectangle and the endpoints of the diagonal are 2, 5 and 6, 3. And we are also told that the other rectangle has an equation of the form y is equal to 3x plus c, and we are required to find out the value of c. So suppose that this is the rectangle. This is one of the diagonals and this is the other diagonal. We are told that one of the endpoints of one of the diagonals are 2, 5 and 6, 3. And we are told that the equation of the other diagonal is y is equal to 3x plus c. We are required to find out the value of c. One of the things that you should notice is that the midpoint of the vertices is common to both the diagonals. So the midpoint in this case will be 2 plus 6 by 2, comma 5 plus 3 by 2. This is equal to 4, comma 4. So the midpoint, which is 4, comma 4, is common to both the diagonals. So y is equal to 3x plus c also goes through the point 4, comma 4. Now we can just substitute the value of 4, comma 4 in this equation to find out the value of c. So 4 is equal to 3 into 4, because x comma y, which is equal to 4, comma 4, is a point on the line, plus c, or c is equal to 4 minus 12, which is equal to minus 8. So the answer in this case is minus 8. The value of c is minus 8.
Google search Krakow free CAT mock. Click on the first link. You can attempt a free mock test which was attempted by 30,000 CAT aspirants in the actual exam format. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solution to get video solutions from our expert faculty.
In this question, it is given that ABCD is a quadrilateral which is inscribed in a circle with center O. So suppose there is a circle and ABCD is a quadrilateral within this circle. So ABCD is a cyclic quadrilateral. We know the definition of a cyclic quadrilateral. Whenever a quadrilateral is inscribed within a circle, the opposite angles add up to 180 degrees. That is the definition of a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral add up to 180 degrees. This is the first thing that we should learn in this question. Similarly, the opposite angles, the other pair, also add up to 180 degrees. Now we are given that COD is 120 degrees. So O is the center of the circle. So COD, this is given as 120 degrees. And if angle BAC is given as 30 degrees, so if we connect A to C, this angle is given as 30 degrees. then the value of BCD is, we are required to calculate the value of angle BCD. So let us first divide BCD into two parts. One, we can calculate the angle OCD, and then we will calculate the angle BCO. Then we can sum up the value of BCD. Calculating the angle OCD is quite simple. If you look at only the triangle O, C and D, two sides of the triangle are the radius of the circle, so they are equal. And because the angle at the center is 120 degrees, the other two base angles will equal, and they will equal 180 degrees, which is the total sum, which is the sum of all the angles in a triangle, minus 120 by 2, so this is equal to 30 degrees. So angle OCD is 30 degrees and angle ODC is 30 degrees. Now we need to calculate the angle BCO, that is this angle. We don't know that as yet, but remember that it is given that angle BAC is 30 degrees. Once you know that angle BAC is 30 degrees, the angle BOC will be twice the angle 30 degrees. So this will be 60 degrees. Why is that the case? Because the second thing that you should know over here is that angle subtended by a chord at the center will be twice what it is subtending at the circumference. This is true for any chord. So if you are looking at a circle and there is a chord, and if the angle subtended by the chord at the circumference is x, then the angle that the chord subtends at the center will equal 2x. This is true for any chord. So if you are looking at the chord BC, the angle that it subtends at the center will be angle BOC, and the angle that it is subtending at the circumference is angle BAC. If you know that angle BAC is 30 degrees, then it would imply that angle BOC is 60 degrees. Now if you look at only the triangle BOC, here we know that this is 60 degrees, this is O, this is B and this is C. Again over here, the opposite sides are the radius of the circle, so they are equal. So the apex angle is 60 degrees, so we can easily calculate the base angles, because it will be 180 minus 60 by 2, so they are equal to 60 degrees. So if you are looking at the triangle OCD, we know that this is 120 degrees, so the base angles are 30 degrees and 30 degrees. And we know that angle BCO is 60 degrees. So when we want to calculate the angle BCD, it will be the sum of 60 plus 30, so that is equal to 90 degrees. So angle BCD in this case is 90 degrees. We have learned two things. One is that in a cyclic quadrilateral, the opposite sides add up to 180 degrees. And the second one is in a circle, the angle subtended by any chord at the circumference will be half the angle that it subtends at the center. So if this is x, this will be 2x. So the answer in this case is 90 degrees. In this question it is given that three sides of a rectangular park have a total length of 400 feet. We are required to find out when the area of the park is maximum, what is the length of its longer side. So let us assume that this is the rectangular park. The lengths of the sides, let us assume, are L and B. We don't know whether L is greater than B or not, but we are told that 2L plus B is equal to 400 feet. This is given to us. Now we are required to find out the value of L when the area, which is equal to L into B, is maximum. So what we'll do is we'll convert L into B, which is the area, into a function of just one variable. So we'll eliminate B and we'll write B, which is equal to 400 minus 2L in the function of area. So area becomes L into B, which is L into 400 minus 2L. This is equal to 400L minus 2L square. We are required to maximize this. Now when does this become maximum? We can easily find out that this is equal to 2 into 200L minus L square. So this becomes maximum when 200L minus L square is maximum. There are multiple ways of doing it. One of the ways to do it is just using differentiation. So once you differentiate this and equate the first differential to 0, the differential of this will be 200 minus 2L. This is equal to 0, or L is equal to 100. Another way of doing it is completing a square. So 200L minus L square, we can complete a square by assuming that this is L minus 100 whole square. Because the middle term is 200L, we'll divide 200L by 2, so that is 100L. So we'll add and subtract 100 square. So this is equal to 100 square minus 100 square plus 200L minus L square. This is equal to 100 square minus of L square minus 200L plus 100 square. This is equal to 100 square minus 100 minus L whole square. Now we know that 100 minus L is never negative. 100 minus L whole square is never negative. So this value, this function 200L minus L square, which is equal to 100 square minus 100 minus L whole square, this will achieve its maximum when 100 minus L is equal to 0 or when L is equal to 100. Therefore, the area of the rectangle is maximized when L is equal to 100. Now, what is the value of B when L is equal to 100? B is equal to 400 minus 2L. This is equal to 200. So, the larger side is of length 200 feet. So, when the area of the park is maximum, the length of its longer side is 200 feet. In this question, it is given that P is an interior point in a right-angled isosceles triangle ABC with hypotenuse AB. So let us first draw the diagram of the right-angled isosceles triangle. So suppose that this is the right-angled isosceles triangle, AB is the hypotenuse, AB is equal to AC. So let us assume that both the lengths are A and A, then the length of the hypotenuse will be A square root 2. Now we are told that P is an interior point of this right-angled triangle. Now the perpendicular distance of P from each of the sides AB, BC and CA is 4 into square root of 2 minus 1 centimeters. So suppose P is a point in the interior. If you draw perpendiculars from P to each of the sides, all of them are equal. Now what does this represent? It means that P is the incenter of the triangle ABC. That is, P is the incenter. It is equidistant from all the three sides. So now you know that the incenter of the in radius of a right angle triangle, there is a formula which is quite useful. So suppose this is the right angle triangle. Suppose the two sides are A and B and the hypotenuse is C, then the in radius of a right angle triangle is equal to A plus B minus C by 2. So the in radius of the right angle triangle will be A plus B minus C by 2, where A and B are the sides and C is the hypotenuse. So if we apply the same formula over here, we know that here A and B are the same because this is a right angled isosceles triangle. So A plus A minus the length of the hypotenuse is A root 2 divided by 2 is equal to 4 into root 2 minus 1. Now we are required to calculate the area of the triangle ABC. So we will first calculate the length of the side, that is A, and from that we can easily calculate the area. So if you simplify this, this will be A into A by 2 into 2 minus root 2 is equal to 4 into root 2 minus 1. Now you know that this implies that A by root 2 into root 2 minus 1 is equal to 4 into root 2 minus 1. What we have done is simple. 2 minus root 2 is equal to root 2 into root 2 minus 1. We have just expanded it this way because we want to cancel root 2 minus 1 on both sides. This would imply that A is equal to 4 root 2 centimeters. Once you know the base of a right angled isosceles triangle, you can easily calculate its area. The area of any triangle is equal to half into base into height. In this case, both base and the height are equal to A. So this will be half into A square. We know that A is equal to 4 root 2. So that will be half into 4 root 2 into 4 root 2. You can cancel root 2 square, so that will equal 16 centimeter square. So the answer is 16.